So we are going to go live with our workshop. We are still waiting for a few more folks to join in. Once they start, we can kickstart the session and then go from there. So Andy, I think let's wait for another 5 minutes. Let people
Okay, no
come
problem.
online, and then we can get started.
Okay, I have some funny prepared. In the meantime, if you are already joining us, we can spend some time in the next few minutes just saying hello and things like that. Okay, so we will have a session for a few hours. This is not going to be a full day workshop, but this is going to be for a full hour. We'll wait for 5 more minutes, and in the meantime, thank you for joining us. Hope so far Global AI Bootcamp has been interesting. And let's see what happens. We'll talk about machine learning. We'll talk about machines taking over the world and things like that. Okay. Oh, okay. No worries. So it's not live yet.
We are live.
Okay, we're live. Okay, no worries.
No, I
Okay.
think there are multiple sessions going on. So, in the previous session also I posted on Twitter, LinkedIn. Let's just wait for about 5-10 more minutes before we start. I want to make sure people join in. So we are up to 3 right now. I think people will join in, certainly.
Okay, no problem. We have plenty of time. No problem.
Yeah, let's wait for another 5 to 10 more minutes. Let folks join in, and then we can go from there.
Okay, no problem. In the meantime, if you have any questions, if you already have any questions, feel free to ask if you are joining us. And I'll be happy to answer them before we start the session. I haven't seen my cat today. She is probably still sleeping. It's something like 5 o'clock in the morning here. So my cat has normal business hours. I don't, but my cat has normal business hours anyway.
You are anyways working some crazy hours these days, so I don't know how you manage it, but yeah, good. You look fresh as if it's like, middle of the afternoon.
Well, it's in this last year I haven't been able to travel anywhere. I have been at home, but when I travel around places, I don't have any normal times because flights are at 3 o'clock in the morning or 5 o'clock in the morning or some crazy hours like that. So this is perfectly normal for me to be up at this kind of hour.
All right, I have made your session on the top.
Okay.
For those who are joining in now, we are just waiting for a few more
Whoa.
folks. A lot of people have shown interest for this, so we are just waiting for them to join in. We'll wait for another 5 minutes before we kickstart the session.
Okay, so while we're waiting, I think I can maybe show some of the things that we were talking about, some funny business while we're waiting. I only accounted for 2. I usually don't need more than 2 unless it is in person, but you can expect that this will happen in sometime in the future. Okay, so hello everyone. I'm glad to have you join us. We'll start in just a few minutes. Ooh, okay. Okay, so welcome everyone. I suppose we can start. Setu, if that's okay, I'll start.
Yeah, please go ahead.
Okay, so welcome everyone. Glad to have you here. Today we'll talk about machine learning and also Azure machine learning. So we'll have two different things to talk about. One is more like theory, and the other one is a bit more practical. We'll see how to do that, and finally we'll talk about the cognitive services and continue the session from yesterday and try to implement some to give you an idea how to use them. Yesterday was the fun part, today is the hard part. No, I'm kidding. Still very fun. Anyway, my cat again. So yesterday you saw my cat. Every time I'm doing a Azure demo, she shows up and says hello. Hopefully she will show up again when we start the actual Azure demos. I have to say something like Azure Portal or something like that, and then she will show up. And of course, these are some of the sessions I usually do, mostly in person around the world, but in this last year, some of these have to be done remotely. So yesterday I did, and I've already added it here, so I did this cognitive services with Night Rider session, which was very fun to do and brought me back a lot of different memories about the 80s and flying cars and things like that. So this was a very good and fun session to deliver. Hopefully you should be able to see it on YouTube and have a look at all of the cognitive services that I mentioned. Today we will talk about cognitive services, how to implement them, use if you are a developer, etc., how to implement those cognitive services. But of course, I will not list all of the cognitive services that I mentioned yesterday. So I will just cover some examples so that you can get started with the cognitive services themselves, and then have a look at the other session from yesterday and to get some ideas on how to do some crazy things with cars, with IoT, or with any kind of app on a phone, or anything else that you would like to do with cognitive services. But that's for the second part of the session today. For the first part, I will actually cover machine learning, and that's based on a session that I usually do for about an hour, which is Machine Learning is Full of Stars and Azure Story, which is version 2 to a session I had before, which is if a machine can learn, why can't you learn Azure Machine Learning, which was the title of the session that I delivered first. And this was delivered about 40 times so far. And this is going to be a workshop today that I've been delivering all over Europe in the last 2 years. I'm not sure how many workshops I've done like this, but maybe a bit more than 10, I'm not sure, but typically always in person. I think this is the first time I'm going to do this specific workshop remotely. I usually do a lot of training, official Microsoft training, but this workshop is a bit more personalized, a bit more fun, if you wanna make it like that. And I've been delivering that about 10 times all around the world. But hopefully in the future I will be able to go in person and deliver it again. Anyway, let's move on and try to see some interesting things. So as I mentioned, we'll talk about machine learning using Azure, and there's a lot of different ways to do this. I have a full list so that you can see all of the possibilities of doing machine learning. We'll have a look at some of the technologies available for that. But before we start, we need to understand how machine learning works. Don't worry, I'm not going to do all of the crazy university things that you need to learn about how to do machine learning. That's going to take like forever. I want to do the fun stuff, the interesting stuff, and especially the easy stuff to get started. So we'll have a look at how this is done, and then we'll move on to the actual technologies. So again, this is me, not that much hair, so I usually have much more hair, but of course I have no idea how to cut my own hair unless it's an all or nothing kind of technique. And to do that, as I mentioned yesterday, this is the very advanced technique that I use. It's called the delete button, so it deletes everything. Select all and then delete. Anyway, if you'd like to contact me at any time, just go to andy.pt or find me on social media, on Facebook, LinkedIn, Twitter, etc. I will be around to answer any questions from you. We also have some Facebook groups specific for Azure. So you have things like Azure Ask the Experts group in Facebook. So anything related to Azure, anything, it doesn't have to be machine learning or anything like that. You can just go there and ask. I also have a few user groups in Portugal. So you have the Data Community Portugal user groups, and all of these have user groups groups on Facebook that you can join and interact and ask us questions, as long as you know Portuguese, which everyone does, of course, or that's okay. If you know English, everyone understands English in Portugal, so it's very easy to do. So you can go to Data Community Portugal, ask any question you'd like, PowerShell Portugal, IT Pro Portugal, etc., and a few more that I take part in for Portugal and for other countries. And we're always ready to answer any question from you that you have about machine learning or anything else. Okay. So anyway, let's have a look at some of the things that we're going to cover today. By the way, I was supposed to hide this slide, but let's show it again, okay? If you haven't seen this yesterday, I actually thought that I hid this, but as you know, last year we've seen a lot of different monoliths going around the place. If I'm not mistaken, this one is in Australia, this one is in Romania, this is in the United States, and of course we have McDonald's. We might have Burger King as well, but McDonald's came first. And then, of course, if you live close to a region that has oceans, like the one you see in the background in my camera, then in that case you probably have this kind of monolith so that you can take a shower after you go into the ocean. By the way, the image you see in the background is here in Lisbon. It's called the Belém Tower, and it's one of the most interesting monuments here. And in the usual days, all of this bridge that you see here to go to the island, where you have that fortification, is usually full of people trying to get in. Most Portuguese people don't even go inside there because it's usually full of tourists, and we just want to go away. Anyway, let's go into interesting things. And I do apologize that one or two of these slides I'm actually here in the front. Okay, I do apologize for this, but it's usually not interesting. And if it is something that's actually interesting, I will move the image so that we can see in the background. But basically, the first thing I wanted to talk about is. First of all, we need to talk about some theory. And by the way, the theory here is that you have artificial intelligence and you have machine learning, and most people confuse the two. It's people mix the two together. Are these the same thing? Are these different? These are actually not the same thing. So before we actually get started with practical things, just to cover a few very small basic things, so that we can understand what kind of things we're talking about, all the naming conventions, etc. I promise you, I will try not to make this boring, okay? Because otherwise, I know you have better things to do on a Sunday. But let's keep it interesting. I promise you, you don't have to read the whole book about machine learning. It's always interesting if you do, okay? But I think this is a good way to get started, the easy way. Okay, so first of all, what's artificial intelligence? And artificial intelligence is what you talk about, and you assume that you see that in the films, and it's something like HAL 9000, like you see here from the film 2001 and the film 2010. Which is supposed to be a machine which is intelligent and can reason with people. Of course, we're not there yet. We are very close. We've seen things like Cortana, Alexa, Siri, etc. These seem to be intelligent beings that you can interact with. These are actually not. My cat is more interesting than that. She's more intelligent than that. But still, we need to understand what machine learning actually does. And remember, machine learning is not that much more than programming things. You can use C#, you can use Python, you can use anything you want to program things which look like artificial intelligence. But one of the things you don't have with artificial intelligence, at least not yet, I'm not sure if we ever will, is consciousness. So I know that I am a person, I know that I exist, but the machine does not know that. The machine only has the programming associated with it. Now, let's mention a few examples about about artificial intelligence. Let's say that you have an artificial intelligence program, and this is a program that's been programmed by a developer that did a lot of codes in whatever language, and that person needs to solve a particular problem. I usually use an example which is a maze, so a labyrinth, a maze, something like that, where you have a mouse and you have cheese inside of that maze, and you put the cheese somewhere in the middle or wherever you want, and then you let the mouse go in and try to find the cheese going around the maze and trying to find it. Now, this is not very difficult for the mouse, because the mouse has a nose, so the mouse can smell and try to find the cheese. But if you are a machine, this is not that easy, because you can only base yourself on the metrics that you have available. So what are these metrics? Let's say you are a robot and you are trying to find, I don't know, an Energon cube or something like that, if you understand the reference from Transformers. So we need to try to find something inside of that maze. And to do that, let's say you are a robot and you can go left, you can go right, you can go to anywhere in the maze, and you have to find the path through the maze. Now, if you remember from university, even if you didn't take machine learning or anything like that, as long as you took something like electronics or computers, you probably understand how to use graphs. And graphs usually have a very easy programming way. So it's just a few lines of code where you can take a graph that has, let's say it's a tree-like graph. So you start here and then you can go left or right. You can go left or right again. Let's keep it simple and just use left and right. But you can go through different places until you find the end of the maze. Of course, the maze goes back, but let's ignore that part for now. And one of the things that happened is that you have 2 or 3 different algorithms to traverse the graph, and some of these are more efficient than others. So you can try an algorithm which is depth first search, which is you try to go, let's say you start the graph, you go always to the left, to the left, to the left on that graph, and then you're trying to find the cheese. If you go to the end of the graph and you don't find the cheese there, you go back to the previous location, and then you take the next right instead of left. If that fails, you go back, you go back, you go back, and you change the route every time, or you just go back a bit more. And then towards the end, you either find it or you don't. Let's assume that you always find something. So on average, you will take about 50% of the time to find it in a random location, which is still okay, but you sometimes want to optimize this. I'm assuming that the mouse will take about 10% of the time during the maze, because they have some interesting sensors, which are your nose and maybe something else. So what happens here when you have this kind of scenario? You need to get some leverage. You need to get some intelligence, because doing just the graph traversal is not enough. Now, a different kind of graph algorithm that you can use is the horizontal search, or level search, whatever you want to call it. The name is different in every language. So what you do is you find all of the locations at the first level, and then if that fails, you go to all the locations on the second level, all of the locations on the third level, and so on. If this is a robot, this might not be the most optimized one. This is great for computing, but not so much if you have to actually take a path and drive and things like that. That might not be easy. Depth first search is probably more efficient if you have to actually drive, go from point A to point B, and it takes a bit of time. But in any case, there are other algorithms that you can use. You can create your own, etc. And then you need to traverse all of the labyrinth to actually find things. Because you don't have the characteristics of the mouse, you don't know where things are. But the mouse has something that in artificial intelligence we could call it something like heuristics. And heuristics are a very crazy name, which is very difficult to pronounce. It's very strange. It looks like magic when you start, but basically it's a simple thing which tells you that you have some additional information, which I'm not going to go into the details how to process that, but you have some additional information that gives you some leverage on to go, instead of going fully to the left, you go to a specific place first, a specific area of the maze, and then you try the other ones, because you know that for that specific area you have more probabilities of finding that thing in specific places. Now, this is all okay, and you have heuristics being used in a lot of different technologies. One of the examples of that is the antivirus programs you have on your computer, and these are fairly easy to use, and they detect some characteristics of the virus, not the actual virus itself, but some characteristics of the virus that make it virus-like. So things like bits of code that say we'll try to infect this like this or like that, but not the actual payloads. Payload might not be interesting, the actual virus itself might not be interesting, but the actual fact that you say let's try to infect this, that can be something that's common with all of the viruses, and you try to find that specific thing instead of the virus itself. Now, of course, you need to solve some specific problems with artificial intelligence. What's the big difference between artificial intelligence and normal programming? Well, in normal programming, you have an algorithm, you decide what you want to do, and the result is usually deterministic. You expect to know, based on an initial set of circumstances, you expect to know what the result is going to be. However, if you are using artificial intelligence, and especially if you are using heuristics, you might not have that possibility in that case. So things might be different every single time. There's a randomness factor associated with this as well, which might be interesting to add in these scenarios. But anyway, also another factor that comes into play a lot with artificial intelligence is defining time. So let's say that you have different processing times for things, and you decide, oh, look, I'm going to try to process something and specify a maximum amount of time, and whatever comes out of that that result, that's going to be whatever I use. And if you wasted 5 more seconds, maybe you've gotten a different result, something like that. So that can also affect it, and it's not going to be that deterministic. But still, in most cases, on average, or statistically, if you want to call it like this, the result should be very similar in any case. Now, what should you do with artificial intelligence? So first of all, the objective is always to solve problems. But then again, you need to do some decisions, and decisions aren't done by the programmer. The programmer tells the machine what kind of decisions they can do, what kind of decisions the machine can do, and how to decide on what decision to do based on those heuristics. And those heuristics are usually found by doing things like machine learning, getting information from previous scenarios, having statistics for a lot of different things, and based on that you do the decisions and make some actions based on the decisions, but not based on the programming itself. Now, machine learning specifically is completely different. Machine learning is very predictable, at least statistically predictable. Why? Because, first of all, let's mention what machine learning is. It's a subset of artificial intelligence. So you have artificial intelligence as a whole, and one of the parts of artificial intelligence is going to be the machine learning itself. Machine learning has a lot of algorithms. I'll show you a few in a bit, but the idea here is that you can use machine learning to learn from previous data you already have, and then of course use that data to make decisions. So you can make decisions yourself as a human, and for that you can use things like, I don't know, even Power BI can receive information from machine learning, or many other technologies that you want to use. But you can also use that in artificial intelligence. Let's say that you want to run a talking car, like the example I did yesterday in the session. You can use that in IoT, you can use that in intelligent houses, etc. So you can use artificial intelligence based on the information that's already there from machine learning. But machine learning, as I mentioned, is based on algorithms. The algorithms are very well defined, and the algorithms have specific objectives for each. You have to decide which algorithms you need to use to do the training. Although in some cases you can use AutoML to just choose the algorithms automatically based on a lot of different trainings, and then you just choose the best, but we'll see that in a bit. And of course you have the objectives for machine learning, which are either to predict things. So what's the temperature going to be tomorrow? Do pattern recognition. You can even do things like trending. You can do trending, let's say, for today is going to happen something to know what's going to happen tomorrow based on the information from before. Things like doing association to understand if someone buys this, will they also buy something else based on other people that buy similar products. And then, of course, you can do answers like yes and no, etc. But we'll see some of these examples for the clustering, for the regression, for other things like anomaly detection, etc. We will see that in a bit. Now, I've taken this slide somewhere from the internet. It's partially wrong because statistics should be inside of machine learning as well. There's a clearly defined exclusion here with statistics and machine learning, but it should be inside machine learning as well, because statistics are actually very important for machine learning. So what you have here is that if you work in databases, let's say your normal scenario of, an application like human resources, something like that, you are typically down here. If you want to do talking cars and IoT and things like that, you were usually here in AI, but always typically based on something which is machine learning. But then, of course, somewhere here in the middle, you always have things like BI and data mining, etc., so that you can make sense out of all of the information that you receive. And of course, these are all interconnected. I'm not going to go into a lot more details with this. We'll have to explain all of this in detail just to give you an idea how these things work. But of course, if you are using machine learning, you can go and fetch the data from those databases and then process it in machine learning itself to detect trends, to do predictions, to study what happened in the past, etc. So you can do a lot of those different things. Okay, so just one or two more things of theory, and then we'll do fun stuff. Typically, the algorithms are of two different types. These can be supervised or these can be unsupervised. And please bear in mind that the list that you see here is not exhaustive. It's just a few examples that I can give you, but the list, of course, is very much detailed, and supervised and unsupervised can actually mix together in some cases. So what's the difference between supervised and unsupervised? With supervised, let's say you have a table with information and you have a lot of columns in that table, and let's say that the last column is the thing that you want to calculate. Let's say it's a bank loan and you have a lot of information about the person in all of the columns, so each line is going to be one different person, of course, and you have information such as age or birth dates, depends on what you need. You have things like education, if this is high school, university, etc. What type of job do they have, if they are married, if they have kids, a lot of different things that might go into a bank loan. And then the last part is going to be if they paid for that bank loan or not in the end. And based on that information, and this can't be just one or two values, this has to be like 1,000, 10,000, 100,000 different values, so you can do proper training. Something less than 10,000 is going to be very bad in terms of machine learning. So something bigger than that is ideal for you to do machine learning training and get some useful results out of that. Otherwise, it won't be very useful. It won't be machine learning. It's just the same as an if clause or a where clause in a database. It wouldn't be very good. But the idea for the supervised one is that when you do the training, when you feed the information to machine learning, in that case, you already have the answer. And then you have to tell machine learning to learn how to find the answer based on the first columns and then get the last column. And this can be one column or more than one column to detect. It doesn't have to be just one, okay? But let's assume one to keep it simple. And in that case, you have to learn how to find that last column. If it is unsupervised, this is going to be very different. So you have no idea what the outcome is going to be. And in that case, it's things like images and things like that. Of course, this can also be tabular data, so it can be a table as well. But in most cases, unsupervised is more typical for images and other scenarios like that, where you have no idea what to expect, okay? You are doing training to find some scenarios, but you don't know what to expect in most cases. But anyway, let's have a look at some examples. And before we go on to statistics, someone sent me this once after I did a session, and I've decided to actually add it to the slides. And this is true, by the way. Statistically is a list less than 1, 0.9 something something something, but this is true. And I'm not sure if you remember, there was a graph where you have a dinosaur or something like that drawn with points on the map. But if you do the average of all of those points, you get a straight line, because you have values on top and then values in the bottom, and those contradict each other. And then you can draw a dinosaur, you can draw whatever you want. But then statistically, the average of things is always going to be a straight line, which is not going to be useful for you. So don't trust statistics that much. Statistics are very important for machine learning, but please be careful how you interpret those statistics, because if you are an alien coming to Earth and trying to find this, and this is the answer that you're going to get, so you will not understand this logic with human beings, okay? It's strange. Statistics does not work very well. Okay, so let's go to the first algorithm that you have. So typically you have algorithms for regression. And when you have algorithms for regression, typically you get a value which is a numerical value. So let's say the example of weather, let's say temperature. You want to detect what temperature is going to be outside. It doesn't really matter. It broke the graph to a negative level so far. It's going to be something like 10 degrees here in Portugal or something like that. It's a completely low value for us. Very cold today. But if you use machine learning for that, you'll probably not be able to detect it. This has been a very crazy year, even for the weather in this winter. So what you get, let's assume that this is a normal time, and let's assume that you have things like the weather that you want to predict, or you want to predict something in economics and biology, many other things that you can use with linear regression. And linear regression is very simple. You learn this in school, okay? So what happens here is that you have a lot of different points, and these points are based, you have the x down here, so for each x you draw a point which corresponds to a specific value. And let's say that this is temperature. Let's say that this is 20 degrees. By the way, I've copied all of these examples from the internet. These are not the real examples. They just looked good, and I just dumped them here in the slides. But these do not correspond to actually anything, so don't mind the actual numbers, okay? But let's say that this is temperature, and the average of temperature, let's say that this is January, and this is somewhere in August. So the values throughout the last 100 years could look something like this. Okay, but in that case, you have a very good technique to predict what kind of value is going to be here somewhere in March or something like that. You just follow the line that gets the kind of average of all of these points, and then you just point to that day in March, and you go here and you find out, oh, it's going to be 40 degrees or something like that in that specific day. So, of course, you can predict a specific numerical value. If it is temperature, when you get temperature, you never get an integer value. You get a decimal value. Usually people present it by rounding it up to the nearest integer. But in practical terms, for regression algorithms, you always get a numerical value, which is decimal, and then you do whatever you want with it. Now, what happens here is that when you get all of these things, these might be wrong, this might be right. So, example here on top, this is completely wrong. So you have some values here which are a bit of an anomaly up here, but still they correspond to all of the things that were detected in the past. Of course, this is the simplest one. You have more complicated ones. So let's say you have other algorithms which can try to find a curve that looks much better than these dots, but of course you might be doing that, doing something called overfitting, and if you are doing that, that's going to be just crazy because you are overfitting to, let's say you want a curve that goes through all of these points. You might find a formula that does that, which is fine, but in that case you are overfitting. So any new value that comes along which is not in the training will probably get a completely wrong value. So you have to be careful not to exaggerate on the training. But for the linear regression is always the same thing. So you always get a straight line. The straight line is easy. There's a simple formula for this, which is a plus bx. So the x you have, the y is the result of the formula, and then you have the a, which is the value from 0 all the way up to 20, let's say 25 here, which is going to be the a. So the formula is going to be y is equal to 25 plus b, which is going to be the inclination of that curve that you see there, and then the x itself. So this is the simplest form that you have. You have a and b, which are the results, the values that you need to store in something called a model. So after you do the training, you get these values of a and b, and then you can do the exact prediction, which is you apply a and b to whatever value of x that you get during the prediction, and you get the result of y. So let's say if the value is here close to the number 60, you go all the way up, and suddenly you have 50 here on the left. So that would be the prediction value, okay? This is a linear regression, the simplest one you can understand, and probably the only one any normal human, and I mean normal, any normal human can understand. If you look inside of a model file, you can see the A and B. For all of the other ones, it's just impossible to understand what kind of crazy numbers are inside, okay? But this one is fairly simple. We can understand this as human beings. Actually, anyone in high school should be able to understand this. Anyway, you have another one which is called, before that, we have, as I mentioned about statistics, which was really bad. But if you try really hard and if you squeeze your data and try to manipulate your data as much as you can actually change the values completely. So please be careful in the way that you process your data so that you don't skew your data to something that's completely wrong, okay? This is not easy to do, by the way, but just be careful because this will be something that can fail your data. And one other thing I need to mention, which is don't, in this case, typically these algorithms are applied by data scientists. If you are not a data scientist, I don't find myself considering myself a data scientist. I prefer to consider myself a developer, but still, once you do data science, once you do any kind of thing like machine learning, etc., you need to understand the business, okay? And this is very important. So let's say you have a specific trends in your business. Let's say you have supermarkets and you have to understand the trends of things that people buy, etc. You need to understand the business. You can't just be a data scientist, like a Sheldon style data scientist on an abstract level and say, here's the table, calculate this. You need to understand what the numbers mean. And an example of this is when you have dates and when you have specifically birth dates. Okay, so what are birth dates? Birth dates are a specific date in time, and if you are comparing an event which happened today at a specific time with, let's say, 1,000 people today, okay, let's say you are doing a race and trying to figure out which one is faster, which one is slower. If you are using the birth date and all of the metrics for the event are for today, the birth date would be okay. It's a date, you can find it, it's a sequential number, you can use it, that's okay. However, if you are doing purchasing history for the last 20 years in the supermarkets, and this is the example that I usually give, so apologies because this is 1 year late, but just assume that this is still 2020. It still is in our minds for most people, but let's assume that you are born in 1950, and you have two people that are born in 1950, so you have a column that says born in 1950, whatever day, it doesn't really matter. And then you are a person that bought a specific product this year, let's say 2020 to keep it simple, so you are 70 years old, 70 years old. 20 years ago, the other person, which was also the same age, bought the same product, but 20 years ago. But 20 years ago, that person was 50 years old. So are these the same type of objects? And the answer is, of course, they're not. One of the subjects was 70 years old, the other subject was 50 years old. For a practical usage of machine learning, these are two completely different age groups. So they have to be handled separately. Okay, so I have a cat that also wants to learn machine learning, so let's keep her around for a bit. Okay, so let's keep her around for a bit. She lost her head apparently because the automated system does not detect cats. But anyway, getting back to the example that I mentioned. Okay, wait a minute. She doesn't bite, but she has claws, so she has problems. Anyway. As I was mentioning for that example, I do apologize for this, but cats are unpredictable like kids. And what happens is that you need to transform that birth date into an age. So what age will you transform it to? It's not the age of today, because both of them would be 70 years old. It's going to be the age of that specific sample that you took. And in one case, it's going to be the purchase that you did in the year 2020. The other one is going to be the purchase that you did in the year 2000. One of them is 50 years old, and the first one was 70 years old. So this is going to be the value that you need to get. You also need to transform that value into a different thing. In most cases, you don't care about the exact age. I don't care if I was born in the 1st of January or in the 2nd of January. For machine learning, it doesn't really matter. Right? But it doesn't really matter if you are 50 or 51 years old, but it does matter if you are 50 or if you are 60. So typically you get the age first and then you do bundles of age groups. The typical age groups that you have, and remember that this depends on your business completely, right? But typically you have some age groups which can be from, let's say, 0 to 6 years old, which are people kids that don't know how to read and write. And then from 6 to 10, these are primary school kids. From 10 all the way up to 18, these are high school kids. Up to 25, this would be university or just young professionals. And then from that, every 5 years, every 10 years, doesn't really matter. And then from 65 years old on, you can just have one single group, because if you are retired, the trends that you have, at least depends if this is using machine learning for medicine, this will be completely different, of course. But let's assume just purchasing things in supermarkets. If you are 65 or 85, it's probably not going to be that much difference, okay? But it will depend. Again, you need to understand the business to see if it makes sense or not to consider these people the same age group or different age groups. Anyway, please be careful with the data, because the data is very relevant when you process the information. Okay, so let's have a look at the next algorithm, and I have two or three just to show you. Okay, and the next algorithm is something called logistic regression. You typically use this, although this is called regression, you typically use this for something called classification. And classification is something which is completely different from regression. And please don't mind the name because this can be confusing. This is one of the things that gets confusing in machine learning. But you can use this kind of curve so that you can process information in two-class models. Of course, there are other algorithms to do multi-class models, typically three or more models, but this can be two as well, but typically three or more models. So what's the difference? If you have a two-class model, basically you have things like yes or no, true or false, A or B, and binary choice. So let's say happy or sad, for instance. This can also be a thing. And you saw that in cognitive services yesterday, that we could do happy or sad, and you had a percentage from 0 to 100%. Typically, the positive side is usually, or the yes side is usually 100%, but this depends entirely on the data that you provide, so this can be completely different. But anyway, it is always your decision, by the way. So anyway, when you have a two-class model, let's say the example here, and the graph is about some birds that you have that fly in certain scenarios, etc. But let's say a different example here, which is the one that we can understand a bit better, which is something which is when you take an exam. Let's say that the amount of values you have here on X is the amount of time, let's say the number of hours that you studied for that exam. So let's say if you study more, you typically get values that you see here on top, which are yellow, which are values of passing the exam. If for some reason you don't study that much, typically you will fail the exam, so that means you have the blue values or the triangles here. Okay, so what happens? Well, you might not study anything, which sometimes happens, and still pass the exam. Or you might study a lot and still not pass the exam. So either way. But there's going to be a threshold somewhere. It's actually should be horizontally defined here. But there's going to be a point here somewhere that defines which is going to be the exact best spots. And this is based on the training that you do, of course, which is going to be the exact best spot so that you can detect which one is going to be predicted as positive or passing the exam, which one is going to be predicted as negative or not passing the exam. And for start, you usually start with 50%, but depending on the data that you have, this value can go all the way up to 60, 70%, or even lower than 50, depends on what it is, depends on your data. There is no rule for this, but if you adjust the value, especially with Azure Machine Learning, there are places in the evaluation boxes that you can use, for instance, that you can adjust to try to find the best spot to get the most correct predictions out of all. Okay, but logistic regression can be used for yes or no. Bank loans is a good example. So if you get the bank loan or you don't get a bank loan, okay, there is one thing I always want to add, which is the ethics, okay. There's a lot of things to say about ethics. The session today is not about ethics, but just to mention a few examples here. And remember that if you have a bank loan, if you are working in a bank and you put this in a computer and just assume that whatever comes out is going to be true, that can affect a person's life. So if you buy a house or you don't buy a house, this is going to affect a person's life for the rest of their lives, if you accept giving them loans for a house or not. So to do that, there's going to be a responsibility associated with this. So you want to make sure you get this right. So let's say if you have value somewhere here, these are going to be obvious. Value somewhere here, those are going to be obvious as well. However, if you have value somewhere here, close to the middle one, you are not sure. So the recommendation I will say is, let's say that the threshold is still 50%. And then what you get is that up to 40%, let's say 0 is no and 100% is yes. Let's say up to 40% you say no. From 40 to 60 you say wait a minute. And from 60 to 100% you say okay, give them the bank loan. But in that middle one of 40 to 60%, you can just say, look, I don't have enough information to automatically calculate this as my own, as a computer. So you as a human, you need to decide based on the information that you have here. maybe request some more information from the person, and then decide on this. Because there are cases where you have completely two different people. One of them, let's say, says 59%, 49%, and the other one says 51%. Statistically, they are exactly the same results. Okay, these are the same result in practice, but one of them is going to get the bank loan, the other one is not, and this is not very fair. So you should have a margin of tolerance to add to this thing, so you can just and this is not about machine learning. This is about doing development. This is doing programming, application development, and you as a developer will need to specify. You get the percentage value, and then from there you specify a border in the middle, the militarized zone, if you want to call it like that, in the middle, where you have to say, I'm not going to make this decision for you. You as a human, you have to decide. You have a brain, you have to decide. Okay? And then they get more information from the person. They look at the person and see if the person looks honest or not. Whatever kind of human behavior you need to do to decide if you give them the bank loan or not. But anyway, this is one of the most interesting ones that you have. For many algorithms, and many algorithms use something called a decision tree. Okay, and I want to make sure that you understand what a decision tree is. Okay, and this is just an example. So I have a cat here. So I usually ask someone if they have animals. I've been getting weird animals when we go to the session in person. But let's assume a cat like the one I have here. So the first question you ask is this a mammal? So you have a yes or no. But before this, let me contextualize this, how this works. A decision tree is how a machine can store information in an intelligent, learning-based way. Okay, so when you have algorithms, a lot of these algorithms have decision trees inside, or use decision trees to acquire the information and then make the decision by traversing these trees. Okay, and then you can even join trees together and try to understand common things between the trees, etc. Crazy things that you can do with this. In most cases, all of these algorithms, you don't have to touch what's inside. You can just apply them. It's usually 1 or 2 lines of code, but it's still very important to understand how they work inside. Even if you don't care about the code, that's just crazy codes. Okay, if you ever decide to create your own algorithms for machine learning, you're going to have to do a lot of learning and a lot of work. This is just crazy, but you can do it. It's the equivalent of a developer creating a compiler. Okay, it's just hard work. So in most cases, you use something that already exists. But in practical terms, this is how a machine works. And I can tell you that about 20 years ago, when I was working in the Technical University of Lisbon, someone gave me a challenge to do something like this. This was the first time that I was using machine learning. And they said, oh, you can do a decision tree. We need to present this for, we need to have a decision tree program so that we can present this in a class. So I took on the challenge. This was very easy to do. And with about 20 lines of code, at the time I used Access to get information from a table. And this information that you see here on a tree like this can actually be on a normal, perfectly normal table, like a SQL table if you want to. So this is easy to implement. And as I mentioned, I did something like 20 lines of code to implement a whole tree that can learn for itself and things like that. So this is very easy to implement. But let's understand the example of how this works. So first of all, you have initial questions. So let's say you have initial data and you say, is this a mammal? So you have the information that's here already. Okay, is this a mammal? Yes. So this is my cat. It's a mammal. Yeah, that's true. Do people use it as a pet? Yes. Or if you want to do it the other way around, I'm the pet. That's the owner of the house. This is what I'm told. Apparently, this is true. So people use this as a pet, correct? So the computer says, I have a hamster. Well, it has 4 legs. It has whiskers and it has ears and things like that. Yeah, but it does meow, and that's not typical for a hamster. So no, I don't have the hamster, so I'm going to tell the computer, no. And you are wrong. And then the computer says, okay, so what do you have? Well, I have a cat. So what's the difference between a cat and a hamster? And then I said, well, the cat meows, the hamster does not. So the next question, so they replace the hamster that you see here with, oh, too much. They replace the hamster that you see here with another question that says, does it meow? And if you say yes, that's a cat. If it says no, it's a hamster. Okay, so that's easy enough. So let's say that now you are learning for a dog. Okay, a dog is nice, it's a nice thing. So is it a mammal? Yes. People use it as a pet? Yes. Does it meow? No. So the computer says, oh, it's a hamster again. No, it's a dog. So what's the difference between a hamster and a dog? Well, the dog bites a lot and barks and things like that. So you have to ask another question to distinguish the hamster from the dog. And then you build that tree like this. So this is fairly easy to do. Now, to do this in codes, typically you use things like more than one question, and these questions can be different columns that you have in those tables in the database. So let's say the first column is going to be do you have university diplomas? Yes or no? Let's say this is for the bank loan. And then if you say no, then you have certain values here. And the next question is going to be, are you married, etc. But if you go to yes, so the next question is going to be, what's your current job or something like that. So the second level of questions does not have to be uniform and all equal. So all of these can be different, but these are going to have, typically you have algorithms to find the first set of questions to be the most distinguishable between the two, and then the second one for that subset, the most distinguishable, and then the most distinguishable, and so on. So that's typically what you need to do with decision trees so that you can do machine learning training. But you can do a lot more. So let me give you an example. This is, by the way, this is a decision tree that's a yes or no, a binary decision tree. So it's always a yes or a no. But you can have decision trees which are not yes or no. These can be for specific values. This can have, instead of yes or no, this can be for value 0, 1, 2, 3, 4, etc. Or this can be implemented in completely different ways. So it depends on the algorithm itself. But there is an example here for using decision trees, which is amazing. We won't have that much time to play around with this. I usually enjoy doing this in person, where we get feedback from the audience and ask about this and try to answer all of these questions. And then the audience just votes which is the correct answer or not. But do try this for yourself. Let me just explain how this works. This is a website. The 20q.net is a website that's existed for over 25 years. In the beginning, they promised that if you asked 20 questions at most to you, they would find whatever object you are thinking about. Okay, and they grew in terms of database. Their trees, their information grew so much that nowadays, at least when I started doing this session, which is about 4 years ago, they were up to 27 questions. So they had to ask you 27 questions before they gave up on deciding what it was. And then recently, it was something like 31 questions. So they added something like one question per year on average or something like that, because it grew, I'm not going to say exponential, but possibly exponentially. They had to ask more questions because they have much more details. And they build their own trees, all of these trees. So what they did is that they actually had a lot of information in completely different trees. And then those informations you can do. This is very crude to say it like this, but think about this if you are a SQL developer. And if you have joins in tables, assume something like a join in trees. Okay, so you get the results of that tree. So you limit the tree to something. You get the results from a tree, and then you join all of the trees together and try to figure out where you are in the middle of the forests. Okay, this is something that they do internally. I'm not sure what the actual algorithms are that they use internally, but everyone assumes it's a decision tree. This makes sense. If ever anyone would implement this, it would be with a decision tree. The exact one, I'm honestly not sure. But anyway, the kind of questions that they ask is slightly different. So you have questions that look like this, like the questions for the cat, so animal, is it small? Yes, it's a kitty cat. I'm not sure what animal it was when I asked this. To be honest, I'm not sure. But this was me asking these kind of questions. But the first question is it an animal? Yes. Is it small? Yes. Does it have teeth? Yes. Is it a wild animal? Sometimes. Now, they ask questions of yes or no. And this you saw in the previous slide with the decision tree, with that decision tree that was binary. But you have a lot of other questions. Now, the unknown is something that you say, well, ignore this question because I have no idea what the answer is. So let's ignore the question. It's like doing a null in a SQL database. If you have irrelevant, that just means that I'm asking a question based on what I see in a specific tree, but I'm asking a question which is completely irrelevant. I'm in the wrong tree. I should be in the other side of the forest, if you want to call it like that. And then you have some other ones which are partial. So think about yes or no like a percentage instead of an actual yes or no Boolean value. And in this case, you have something like sometimes, and sometimes let's assume it would be something like 50%. A maybe would be something like I'm not really sure. So there's an uncertainty factor here, but a maybe would be a yes, but not sure if it is a yes. Okay, it's possibly a yes. And then probably is also, I don't know, probably might be a 70%, doubtful might be a 20%. Usually that can also be a 70%, but the difference between the two is one of them you declare that you are sure, the usually you declare that you are sure, the probably you are not very sure. Okay, and then the depends will actually be a bad thing, so I'm not sure how they implement the depends, but they might do something internally to handle that because it will depend on other situations, so it might not be a good question to answer. And then the rarely or partly is also a percentage if you want to call it like that. But anyway, give this one a try. This is very, very fun to do. Okay, my recommendation is try this in English, of course. Each individual language, there's a lot of different languages which are available. The one that works the best because it has 25 years of experience is the English one. So you can do things like characters in fictional things like Star Trek characters and things like that, or rocks, or whatever, plants, animals, etc. So this is quite fun to try. And then you can see this in action where how they capture the information. This is very easy. Anyway, I want to mention one last algorithm. There are many more. There are other algorithms besides clustering, things like doing deep learning with neural networks and things like that. That's a bit more complicated. I don't want to go into a lot of details for that. I just want to mention the clustering here. And this is very good for things like fraud detection, things like detecting trends for certain people, association, etc. So this is fairly interesting to do. One of the most typical algorithms for clustering is going to be the k-means algorithm. And please let me just say that the algorithm is older than me. It's from the 70s, so it is older than me. And the k-means is a very simple algorithm. So what you see here on the screen, and please ignore what this actually means, just look at the image. And let's say you have X and you have Y. And these are two different dimensions of analyzing a product. So these are, let's say, people that buy something also buy something on the left, or different types of things on the left, different types of things in the bottom, something like that. And you can have 3 dimensions, 4, 5, whatever you want, okay? So this doesn't have to be a line or a circle. This can actually be a sphere or a 4th-dimensional sphere or anything else. But here, let's assume 2 dimensions. And then, of course, you see here you have clusters, groups of things. Of course, you have also things outside, and these can be considered anomalies. These are very far away from the center of each cluster. So these can be considered an anomaly, but still, according to the algorithm, these will be assigned to one of these 5 clusters. So the technique here is very simple. We start with any of these algorithms, any of these clusters. So first of all, you decide how many clusters you want, and then you randomly put 5 dots somewhere along the graph in these two-dimensional graph, and then you go to the dots that you put in there, which are supposed to be the centers of these things, and then you detect the closest location to each of the points. So let's say I had a point here where I have the mouse here on top, and then this one is going to be the closest to this point. So this one gets associated with this cluster here, with this center here, and then you have a different center down here. So this one would be associated with that one, different ones. So what you do is you find all of the values which are closer to the specific center, and then you associate that with that specific center. So A, B, C, D, or 1, 2, 3, 4, whatever you want to call each of these clusters. And then what you do is Because you have that, you move the center of your cluster to the center of all of those points, and then you do iterations to detect again and again and again. And in the end, this is so effective that after like 10 iterations, maybe a bit more, depends, you're going to get something like this where all of the values are actually grouped together in clusters. This is very fun to use, so I do recommend that you have a look at how clustering works. It's very fun, but in practical terms, you can just use the k-means clustering, and you get the result very quickly. You just have 1 or 2 lines of code, or of course you can do this graphically in Azure, and you get the result out. You don't need to know how these things work inside, but still it's important to understand how they work and why they work like this. And of course you can detect a lot of different trends. Security is one of those examples on how to detect things, and it's quite fun to use it like this. Currently, k-means, although k-means is very old, there have been improvements of this algorithm in the last 40 something years, something like that, which means that you can use a lot of different optimizations into this, and of course Azure will have some optimizations to make this as fast as possible. Now, before we go into the actual technologies, let me just mention 1 or 2 things, which is sometimes people treat AI as, and this is the best example, they try to use AI, they try to use machine learning, but in the end, if machine learning if machine learning specifically always gets 100% of the values correct, that's not machine learning. That is actually going to be an if clause or something like that, because you're not really doing machine learning. You had so little amount of information in the beginning that you did not do anything that was based on statistics. You did something that was based on very simple queries, so that didn't work. So also please be careful. You need to have a minimum amount of information to work with machine learning. I would say something like 1,000 items in a list, in a table, for instance, would be the absolute minimum I would consider. But I would go to 10,000, 100,000. That would be the ideal to actually get proper values with good quality, with good accuracy in terms of the values. Now, this is available. If you have a look down here, you go to aka.ms/ml, so machine learning cheat sheets, and then you can download all of this information. And you have here, of course, machine learning cheat sheets, and this gives you a few examples of all of the algorithms which are available. This is changing all the time, by the way, so please don't trust this too much. This changes all the time, and if you are using things like Python, any algorithm which is available in Python is also available here. So you can use that as well. So of course you have a few different categories. Predict data between 2 categories. So this is a yes or no, true or false, etc. So you have a few different options. 2-class logistic regression, which was the one we mentioned, decision forests, decision tree, boosted decision tree. You can even use neural networks to do this, etc. So support vector machine is also very typical for these kind of things. If you are detecting multiple categories, so several categories here, and let me just move this to the side for a bit. Multi-class classification, then you can use multi-class neural network, decision forests, etc. So you have a lot of different algorithms if you are detecting A, B, C, D, etc. So let's say you want to detect what kind of job a certain person has, or what kind of country is that person from, for instance. You get a lot of information, and then you have a list of items A, B, C, and D, where you can try to find where the person belongs to. So it's fairly simple to do as well. Okay, you also have the regression, which is you want to predict actual values, continuous values, decimal values. So that's easy enough. Anomalies are also interesting. So you have PCA, 1-class SVM, so support vector machine. You also have clustering. I mentioned the k-means. But if you want to detect other things, you can also have recommenders as well. So you have the SVD recommender also for things like generate recommendations. Let's say YouTube videos, etc. You can use either one. Depends on how you implement this, but you could technically use either one. But things like when you see in YouTube videos, etc., or things on eBay, something like that, people that saw this also wanted to see this or buy this. Okay, so you also have that kind of information. Anyway, you also have things like text analytics. And yesterday we had a look at text analytics done in an automatic way using cognitive services, but you can do this manually using machine learning, of course. And here you have image classification, so you can play around with images. And these are a few examples of things that you have here. They give you some examples of each of the algorithms which are available here. So things like linear regression are typical for regression, Poisson regression, Bayesian linear regression, etc. But you can also use things like decision forests as well to calculate this. So things like decision trees and decision forests and anything related to trees and things like that. You have a lot of different jungles as well. You have whatever kind of things. But all of these are also available in multiple different types of algorithms. So two-class classification, multi-class, etc. also have decision trees, etc. But these are available in multiple places. And you can also use neural networks, which is a little bit more advanced to understand. The slowest ones as well, but also the ones that predict the best. Because they do a lot of mixing together with information. They work pretty much like your brain works as well. Much slower, much more time consuming and resource consuming, but then in the end they have a better accuracy. And the typical accuracy for things like, one of these things like two-class logistic regression or boosted decision tree, a good value would be something like 90-something percent, 95% would be a great value, a good percentage. Anything over that, you ask for exponential time for training. That's just going to be very slow to do the actual training. So still possible, but then you need to figure out if it is worth it to spend that much time doing training just to get a small percentage of better quality in the predictions that you do with the result of that model. Okay, so from this point on, I have all of the theory, or almost all of the theory done. Okay, there is actually one more. Give me a second, because for some reason it jumped out. 1 second. For some reason it actually jumped out. Oh, okay, wait a minute. Okay, so for some reason I accidentally deleted that slide, but I'll show you that slide during the first demo, so that's okay. The kind of content I can show you, but I will later make it available. For some reason I included a lot more slides, but I deleted 1 or 2 accidentally. And I also moved some slides around, like this red line, which was supposed to kill these Azure notebooks. I do apologize for this, but it's still 6 o'clock in the morning here. And I've changed a lot of these slides to different things in the last few hours, and they still have some bugs. The old ones were okay. Anyway, let's have a look at some of the possibilities that you can use to do machine learning. And by the way, as Setu mentioned, feel free to ask any questions over the chat, and I will be here to answer those questions. I will look at the chat window on a regular basis and answer any questions you have. So one of the things I wanted to mention, and we are up to part number 2 of our workshop already, and then we'll have part number 3, which is going to be to talk a bit about cognitive services and how we can implement them. But that's going to be for the third part. For the second part, I want to show you all of these different possibilities of doing machine learning in the Microsoft universe. And to do that, you have things like Azure Machine Learning, Databricks, Synapse Analytics, SQL Server itself. You can use a lot of ways to use SQL Server. You also have, of course, the cognitive services, which we'll talk about later. And for all of these services now, there is a lot of different notebooks that you can use to do the actual coding. And to give you an idea, you can use the Azure Data Studio. So if you are a SQL guy, you can use Azure Data Studio. You can also use, of course, you use Management Studios, SQL Server Management Studio. That's actually the one I prefer to use. But Data Studio is quite good because it allows you to have things like notebooks, etc., so that you can connect to data sources and use notebooks. You can also use Jupyter notebooks. You can use Jupyter Lab. You can use Zeppelin notebooks. DBC is going to be the Databricks notebooks. But there are a lot of different ways you can do it. Or you can just plain do this in code in a command line or in your application. Either way is okay. Remember that the notebooks have code inside. These are just normal codes code files that also have the advantage of storing the results of each execution of each cell of codes. Okay, so there is some advantage there. But let's talk about some of these scenarios. And the first one is going to be Azure Machine Learning, and I will show you demos of each of these as much as I can. Okay, with the time we have today. So each of these we can spend days and days demoing each of these, but I will try to keep this as short as possible to the interesting stuff. So first of all, we have the Azure Machine Learning. It used to be called the Azure Machine Learning Service. It's also used to be called the Azure Machine Learning Workspace. And there was something which is now called the classic Azure Machine Learning Studio, which used to just be called Azure Machine Learning Studio, but it's now called Classic in the Azure portal. It's still there apparently, but it's not something that you should use in the last year and a half. I have a video from the last maybe 3-4 years ago, where I demoed the classic version of the studio. Nowadays, the new version with the new designer are very similar, so there is no difference between the two. So you should use the new one at all times. But you might still have some old things in Azure Machine Learning. Anyway, what you have with Azure Machine Learning is you have an interface, you have a workspace where inside you can store a lot of different experiments. So the results of the experiments, you can store models. So remember that the model, you have the algorithms that you use for training, to train machine learning based on the information you provide. So those are the data sets of information that you provide. And then the result that comes out, like let's say you get all of the knowledge comes in, and then you squeeze all of that model, you distill that model into a few drops of knowledge, and those drops of knowledge are going to be your model. So in that example we had before for A plus BX, which was the linear regression, the A and the B are going to be parts of your model. Okay, so you want to get those results come out, and even if you have a terabyte of information or even a petabyte of information coming in, the model can be something as small as a few kilobytes in size or even less. Okay, even if you take 3 months to do all of the training, the result can still be a few megabytes, a few kilobytes in size, and then you can take that model and put that model in an IoT device somewhere in Raspberry Pi, or I'm not sure if you are able to see this, but maybe a Raspberry Pi. Okay, yeah, this is a Raspberry Pi. Well, this thing here is not very good. The one in Teams usually works best, but still, you can put inside of this Raspberry Pi, you can put a small model like that, a few kilobytes, and then do the predictions. Even if the prediction originated from a data set that had terabytes or petabytes of information. Okay, and it's going to be very quick. It's going to be microseconds to process the thing, so it's going to be very good. Anyway. This workspace has a lot of things like managing your own clusters, where you do the processing, managing virtual machines, managing web services and containers, where you do the prediction web services inside of those containers. You can also send them to VMs if you want to. That's entirely up to you. But you have that. You also can manage things like VMs on the side coming in from HDInsight or from Databricks, etc. So all of the management for this has to be done in some way. And currently there is an SDK using Python, and there is going to be an SDK using R, although in the last few years I've seen R decreasing the amount of importance for some reason. So the support for R does exist in terms of doing machine learning, but not the SDK that handles creating clusters and things like that using code. You can still use the portal at any time, right, to create some of these things. But if you want to do code so that you can put all of this inside of one of the notebooks, in that case, you need to use Python to guarantee that. But then again, each notebook can have a bit of Python and then also a bit of R, a bit of Scala, a bit of even .NET if you want to. It can have a lot of different languages depending on where you are going to consume that notebook. But anyway, the SDK guarantees that you can run a lot of different things into the workspace to get information, to create data sets, to get the data stores, or basically these are the data sources. You can start experiments, view the status, do whatever you want, all using code. And of course, you can run code to do AutoML, and hyperdrive, and these two are special things. So AutoML is your automated machine learning, and these are the things that you typically want to run using the graphical interface, which is very easy. But if you want to do this in code, these are basically 10 lines of code, not that much more. You can reduce that to 1 or 2 lines if you want to, but to make it properly, about 10 lines of code for AutoML with Python, of course, and you can just run it with any way you want. So the AutoML, what it does is, instead of running one training, it's actually going to run a whole bunch of numbers of trainings based on something called the hyperparameters. So every time you have things, let's say a decision tree, you can say how many decision trees you're going to get to create when you are doing training. Let's say you want to create 32 decision trees, 64, 128 decision trees, how many you want, okay? And you can even define for those decision trees, depends again on the algorithm, you can define what's the maximum number of levels that each tree can have, or number of leaves, depends on the algorithm. So you can do all of these parameters for that. Now with AutoML, you don't configure anything, it's fully automatic, but they will run automatically all of these hyperparameters in a different way with different algorithms, but you have to specify if it is regression, if it is classification, etc. Those you have to define. But once you define those two characteristics, the type of algorithms that you want, then they will run a series of different algorithms internally, and then they will tell you this is the best one, here's the model with the most optimized values. If you want to optimize this, if you want to get this is a good place to get started, by the way, the AutoML, so that you have an idea what the best values are for those models and which is the best type of model, 1 or 2 best models, and you have a list of all of them. You can order them by quality and then define, accuracy, etc., and then define which one is the best one. But then if you want to get more details into specific areas of those things and do training just optimizing for those parameters, you can run the hyperdrive, and those parameters you specify the values yourself, and this is much easier to do with hyperdrive. Now with hyperdrive you have to do this in code. There's no graphical way in the portal to do this. You have to do this in code, but it's still very easy. It's still 5 or 10 lines of code. Anyway, you also have something called the model registry, which is something that's typically not available in most machine learning solutions, which is if you are doing codes, machine learning code in your own computer, you have to store all of these files and remember which files are which. But here you can just say upload to the workspace somewhere in the clouds, give it a name, give it a version, and then the next training will have version 2, 3, 4, 5, etc. in there, and then the model registry will always have the most recent version of the model, and then you can deploy that into web services automatically. You just say, get me the last model, or the model for version number 3, 4, 5, whatever, which I know is the best, and then deploy that web service with the best model that I trained so far, and then that will be used. And then when you have a better model, you can just say, now this is the better model, get me a new web service, replace it with the new one, and then you can do it like that. Now with Azure Machine Learning, as I mentioned, sorry, very early in the morning for me. it's still 6 o'clock in the morning here. Anyway, with AutoML, this is all automatic. With hyperdrive, you still have to define the algorithm yourself in that case, but typically use Python. Okay, you can also use R, which is incomplete, but basically you have these two programming languages. If you are, however, using Databricks, and please remember that Databricks is not a technology from Microsoft. This is a technology from a company actually called Databricks, in which they create a layer on top of Spark clusters. When you create a Spark cluster, and by the way, Azure Machine Learning does not use Spark clusters. These are just normal VMs with Python installed. But if you are using Databricks, you install the Spark engine, the Spark cluster, in one or more machines, of course, to create clusters. And these Spark clusters are managed on top with a layer called Databricks. And Azure Databricks is even a layer on top of that that guarantees integration with all of Azure so that all of these machines will be visible to Azure and handled automatically with monitoring and things like that. So makes it very easy. Of course, there's also Databricks with other companies that are not Microsoft and not Azure. But those are not my problem. Anyway, as I mentioned, these are Spark clusters, and when you have Spark, you have things like the SQL engine inside of Spark. So you can do SQL codes, you can use Python code, you can use R, you can use Scala. You might be able to use other languages as well inside of Spark clusters. So what's the big advantage of Spark clusters? Why are people talking so much about Spark? Well, you have other ways to process big data and to process machine learning specifically, but Spark has an advantage for this compared to things like Hadoop and a few others, which is Spark is an in-memory engine. That means that everything you do, you put that into memory, into RAM memory, and then you process it. For instance, if you do big data processing in Hadoop, you typically process something using MapReduce, using something else, but then you process something, you put it back on the disk, process something, put it back on the disk. With Spark, you put it all in memory, you process everything in memory, and then send it back. And there's a big advantage of 10 to 100 times faster processing, which is very important if you are using machine learning, because there the bottleneck would have to be the reading from storage from the disk. That would be the slowest bottleneck. And having everything in memory is actually great. So remember, a logic for a Spark cluster is to actually have a big capacity in terms of RAM, not so much CPU. And you also have something called HDInsight. So HDInsight is a technology that's, and we will see each of this, don't worry, I will show you a demo of each. Let me just compare these first. HDInsight, you have Spark clusters, and these are the same Spark clusters as before. The only difference is that this is also a layer on top, but only manages that specific cluster. While Databricks, you can create 1,000 clusters inside of one Databricks workspace. With this one, you can only create one. So let me just move the microphone here. Okay, so what happens here? If you have HDInsight with Spark, you only have one engine in that Spark in that HDInsight cluster. So if you need more than one Spark engine, you need to create one more and then one more, completely independent. And you also have with HDInsight, so HDInsight has Hadoop, has Spark, has Hive, has HBase. It also has Storm, for instance, if you want to do real-time streaming. But it also has something called the R server, which is, of course, a server that processes R. And then this is one of the alternatives for machine learning as well. Then we have Synapse Analytics. Formerly, this was called SQL Data Warehouse, although SQL Data Warehouse is only a part of all that Synapse Analytics is. Synapse Analytics currently has a SQL engine that does all of the processing like a SQL Server, although this is a distributed SQL Server for parallel data warehousing engine. But you also have the possibility of running this on a Spark engine as well. So this is very interesting to use. With this, of course, because it has Spark, you can run SQL, Python, R, Scala, but you can also run .NET. So if you want to run ML.NET libraries, you can also use ML codes, ML.NET codes, so that you can run it. And of course, you have SQL Server 2016, 17, and 19, which by themselves have SQL codes that you can run, but they also have the possibility of using .NET codes like the CLR.NET code at any time, in which case inside you can have of course ML.NET, but then you also have things like machine learning services using R or Python. In 2016, these were called R services, but then in 2017, these were called machine learning services with R or with Python. So you can use this, and this R one is actually similar to the one you have here in HDInsight. Anyway, with any kind of platform, Windows, Linux, etc., that can run .NET Core, you can also run ML.NET. This is very easy to do. You can also run Python in Windows or in Linux, etc. You can run R the same way. So all of these technologies exists, all of these languages exist, and the magic here is not the languages themselves. I personally find that Python and R are very ugly languages. I come from the .NET world, from the even before that, from the Visual Basic world, in which the language looked good and made sense. And with R and Python, they just look ugly for me. Okay, but the problem is, it's not about R, it's not about Python, it's not about .NET with C#, with Visual Basic, etc. It's not about that. It's about the libraries. ML.NET is a library. It's not a language. It's a library. And in Python and in R, you have a lot of different libraries. That's the important thing that you need to take out of all of the situation. And of course, you have the cognitive services. Yesterday, we also saw some bots in the session yesterday. I will show you how to deploy some cognitive services towards the end. Just a note, so the line here was supposed to be a bit lower. I moved this down, but I didn't notice the line. Just to fit my image here. But basically, there used to be called something called Azure Notebooks. They disappeared a few months ago, so you cannot use Azure Notebooks anymore. So in that case, these are they might still be in some examples in terms of code in some documentation, but they don't exist now. You have notebooks inside of the Azure Machine Learning workspace, Databricks, Synapse Analytics. All of these have their own notebooks that you can use inside. Okay. Anyway, let's do some actual demos. Okay, before we go into this, and first of all, we have to start in Azure.com, and I'm not sure if you were in my session yesterday, but I mentioned very briefly that you can create a free Azure account. So you can just go to Azure.com, click Azure for free, so the green button, and then again the green button somewhere here, and then you have some free credit for a whole month, and then from there you have 12 months of free services like SQL Database, etc., Cosmos DB, those things, and then some services are completely free even after that, like some cognitive services that have some tiers which are free tiers, etc. Those will be completely free as long as you don't exceed certain limits. But for machine learning, typically you need either this first part or this second part here, so either one. The always free might be a bit more difficult, but you can still use it with a free tier. If you are still in a university, you might be able to get some Azure credits from that university. If you are working in a company that gives you a Visual Studio subscription or MSDN subscription for using Visual Studio, in that case you should have some free Azure credits as well that renew every month, so you can use some of this. This is actually how I'm using some of this accounts. Now I have something called the Azure portal here, and this is portal.azure.com. This is where you start everything in Azure, and in this case I have some things that I've created yesterday for text analytics, content moderator, Big Brother, etc., for faces, and just generic cognitive services and bots. But down here, I've created some examples of ML. Why missing for some reason? It was very early in the morning when I created this, and then Databricks, and then Synapse Analytics. So how do you create these things? This is always the same way to create them, and I will show you how to create them this individually, one at a time. So I will start with Databricks because Databricks is going to be very quick, and then we'll move on to Azure Machine Learning, which is much more interesting. So first of all, you go to Databricks here. So you go to new on the left, you say Azure Databricks. Be careful, there's a lot of third-party components which are also called Databricks. So the one you want is Azure Databricks published by Microsoft. You say create, and then from here you are going to create a Databricks workspace by having to define a resource group. So let's say you can create a new resource group, but I've created one just for this. At the end of the session today, I'm actually going to delete everything inside this resource group because this is actually going to cost a bit to load all of these things at the same time. And I did not save any money for this because some of these have good capacity, so that I make sure that these work in the demos. You never know, but still, this cost a few euros per hour each, and then I'm going to kill them. But you can get lower values in terms of performance to make it cheaper, or if you have free tiers, that's even better. So you give it some name. So let's say Andy Databricks 2, Databricks 1 already exists. You have to define the region, so this will be a region close to you in most cases, or close to whatever client is going to use this, of course. And then pricing tier. If you want to try Databricks for 13, 14 days, you can try the premium and then delete it before you start to actually pay for this. But remember that the trial is probably the ideal, because you have, for each of the clusters that you deploy, you have to pay a certain amount of DBUs, which are database units. This is a certain amount of money that you have to pay for licensing each of the clusters that you deploy. Okay, so in that case, if you use the trial, those are free anyway for 14 days, so you might as well use that one. After 14 days, if you kill it, that's okay. If you don't kill it, you start paying for them. Okay, so anyway, networking. I'm not going to go into a lot of details for security. In this case, you can put this into a virtual network for added security. But for most of the demos, I usually recommend just for demos, never ever for production. I usually recommend just to put this as public things, so that anyone in any part of the internet can see it, so that you don't have to debug your connectivity before you actually try out this new technology. But once you do this into production, make sure that you do this in proper virtual networks, etc., with the necessary levels of security. And then you say review create, and then you say create. Now, I'm not going to do that for obvious reasons. That would take about 10 minutes, something like that, to deploy. I've already created this, so I can just go here to dashboards, and then go to my Databricks account. There's a lot of interesting information here on the left, etc. You can change your virtual networks at any time. All of these things are available here. But what you really want, actually, in all of these machine learning workspace, Synapse Analytics, etc., is to actually press the button that says Launch Workspace here. Okay. So once I'm actually here already, so I'm going to be lazy and just use it. And if I am here, the first part that you have here is, let me just go here. Okay, just make sure that this is running. Okay, too many accounts. And when I have this here, what's actually going to happen is that this is going to be the first page. You have empty notebooks, you have quick start. This is going to be the one I'm going to use. But then you have import, export data, which is also interesting. And then a lot of documentation, common tasks. All of these common tasks are actually here on the left as well, so you don't need to worry. Okay, so first of all, we need to understand what a workspace does, because this is a nice interface, graphical interface, so that you don't know how to do everything manually. And the first part you need to go is to your clusters. Now, you need to create a cluster. I've created one already. This is already here. But you need to go here and say create cluster. And then let's say cluster 2, or let's call it 3. I'm not sure if I have a 2. I don't, but anyway. You define cluster mode standard or high concurrency. You can also define it as one single node if you really want to. This is more recent. This might not be in some of the documentation. This is only a few months old. But in any case, you can use it. You can also define pools of clusters, so that every time you run something, you just define that this is going to be in a pool of clusters, and then this will run the first available one. And then you can define the version of Databricks. 7.4 is usually very stable at this moment. You can define 20 more down here, so you can go to older versions. And if you define GPU, that means that the hardware, the virtual machines that you use are going to have graphical GPUs, so that you can do machine learning process using GPUs. This is great for things like neural networks, etc., and other machine learning algorithms, so you can use that one. In any case, one of the things you might want to use or not depends on the capacity. So you have things like auto-scaling to define minimum and maximum number of workers. If you want to make this the smallest possible, you can just go here and say, look, I just want one worker, which is one worker of the minimum capacity, which is 4 cores of CPU. But then remember, you have to pay 0.75 dBUs of money in terms of licensing. But then you have the driver type, which is going to be your control nodes. So you typically have one control node and then multiple working nodes, so that you can do whatever processing is inside of the Spark cluster. So I can just define this. There's a lot of advanced configuration here that you can do. So you can also do a lot of advanced configuration, like adding scripts, initialization scripts, etc., logging, a lot of different things. I'm not going to go into a lot of details here, but you can just say create cluster, and they will create a cluster for you. In the meantime, you can just go back here to the clusters, and you have cluster 1, which is running. You can start it, stop it, kill it, duplicate it, clone it in this case, of course, or just create a new one. And then you can have pools of clusters, and then you can have job clusters so that you can run automated jobs every X number of hours or specific hours, etc. Once you do this, let's go to data here, and data allows you to, bug, okay, that's a nice bug. Okay, wait a minute, is this a login thing? Might be. Maybe it's a login thing. Yeah, it might be a login thing from the other session, which was stale for about 1 hour or two. But let's go into this one. So you have the possibility of creating tables. Tables are basically your data sets, okay? So you need to create a table, so you can go here and upload a file. That's one of the options. And you store this inside of Databricks file service, file storage here, and this is created for you automatically when you create Databricks. But you can also use that one from already inside the Databricks file system from here already, or you can get other data sources, which is interesting. So you can get blob storage or data lake store from Azure. These are pretty much the same thing, except in terms of some optimizations and in terms of security. But these are pretty much just storing files for practical purposes. And then you can get information coming in from Cassandra NoSQL, or from Kafka Redis Elasticsearch, or if all fails, you can get information from JDBC. And if you do JDBC, you can just say create table in notebook, and they will create a notebook which is basically empty, with a template that says, look, define what kind of driver you want. This can be Postgres, this can be SQL, whatever you want, and then you can just define the connection string, etc., username, password, etc., and then the connections, you add that information here to the JDBC, and then from that point on, you can just get the information from here and then use the information. And here's just a few examples, okay? So what it actually does is that it generates code for you to use with some of these, and then you can just get the information. If you want to know more about this, we can try the quick start tutorial. Now, I'm not going to run it because it might fail drastically. Well, technically I can run it, it's okay. I do have a cluster that's already running, so I can just say, look, let's run all of this, okay? And it will take a few minutes to do this. So when you have this kind of notebook, remember that the notebook in this case is a SQL notebook, okay? But you can have a notebook in Python, Scala, or in R as well. But in this case, all of these things are in SQL, and they are actually running these things gradually. So we'll see what happens. It will take a bit of time, but for instance, the first thing you need to do is follow the instructions and then see the command. So this one just says drop table diamonds if it exists, and then gets the tables from an example which is already created for you. So you can use this one, which is a diamonds table, and this is what it looks like. So you can get the information coming in from a storage account, and then you get the results as a SQL table, but inside of Spark, and this is in memory, so this is all in RAM memory so that you can use it faster. But then if you want to use Python inside of your code as well, this is also very easy. You can just say reads from the same location, and then create the diamonds data frame, and then from there you can just save that to something called a delta store, which is something where you store on storage, where you can read and write in multiple locations. This is very practical if you need to interact Python with things like R or Scala or the SQL worlds. So the next step here is going to be drop something, and then I can just, and going back to the SQL world now, you can create a table, but based on that delta location from the Python. So it's very easy to get information in Python and then use it in the SQL engine. So if you know a lot about SQL, but don't know a lot about Python or vice versa, you can run some things in Python, some things in SQL, and then run all of these sequentially, and then just do whatever code you need to do, some ETL to, to clean up your data, to do whatever you need to do in the language that you are most comfortable with, and Spark will run all of these languages for each thing. And then there are some processes which are much better in Python, some processes are much better in SQL, so it's entirely up to you. And then the result is going to be very similar. So this is the similar results coming in, but then you can manipulate things. So if you do group bys, you get results that look like this. So you order by color. By the way, color is actually not the actual color, it's the number, it's the letter that you see here. Letter D is a color of diamonds for some reason. I'm not sure what they actually mean. I never bought a diamond, so I'm not really sure. But basically, they've told me this is actually the other way around. The most expensive diamonds are actually the other way around. But, I have no idea what they are. But anyway, for this, you can change this into different formats if you want to. Okay, so you can try pi, and you can try any of the other ones. So some of these are interesting. Let's say map is not going to be very good in this case, of course, but line should be okay. And then you can do plot options and then manage all of the options for each type of graph. And then you can adjust all of this. So this will actually show up in your notebook. In Databricks, you can run notebooks automatically using jobs inside of Databricks, or using things like Azure Data Factory to orchestrate executing Databricks notebooks. You can also run them from inside Azure Machine Learning if you want to as well. So all of these technologies are actually interconnected. Databricks, Azure Machine Learning, even HDInsight, and also Synapse Analytics are all interconnected, and Data Factory as well. They're all interconnected, so they can call one thing from the other, which is very, very practical in most scenarios. So anyway, you can repeat the same operations using Python, but in this case, you are getting the information coming in again, but then you are going to run the exact same query that gives you the same results, but this time you are actually using Python instead. Okay, so this is a great quick start for Azure Databricks, so that you know how to do these kind of things. And of course, you can run all of these as well. With all of these are available, but you can also see the codes, the actual values that are behind this, not in a graphical format, but in behind this like this, so that you can, these are the raw format. You can download them if you want to, etc. And of course, if you have Python here, you can run machine learning. I'll show you some examples of machine learning, but inside the Azure Machine Learning Studio. For now, just assume that it is perfectly possible to do it inside of Databricks. Okay. So anyway, let's go to see a few more things. So you have jobs. So let's say that I have that specific, by the way, that specific notebook is going to show up here inside my workspace. This is my user. I can have more than one user if I want to, and then I can have as many notebooks as I want inside of here. And then once you have a lot of notebooks, you can go to jobs and say create a job. And then I'm going to say that I want to create a job that runs that notebook. So this is going to be something, and then I'm going to select a notebook, and this is going to run my quick start notebook. Okay. And that's going to run on a schedule, so you can define the schedule every hour, whatever definition you do with the every hour, every day, whatever. And then once you do that, you can say active runs, run yes or no, run with different parameters, wait for that to run, see the results that I have ran in the last 60 days. And of course, you have other things besides the jobs here as well. Okay. One of the things is the models, and with the models, every time you do machine learning, you can save the models, you can register the models inside of this model register here. You can say create model, upload a model from give it a name, and then upload some values. But we'll have a look at the equivalent of this in Azure Machine Learning workspace, and this for the models here is actually fairly recent. It already exists in Azure Machine Learning for a long time, but here they've only started to add the models here fairly recently, in this last year, something like that. Anyway, let's have a look at the next one, which is Azure Machine Learning. In the meantime, if you have any questions, feel free to ask. Okay, and we still have about a bit less than an hour to go in this workshop. I will try to finish this workshop in time for you to see some of the sessions, machine learning sessions that still exist in the at the end of the main track. Let's call it like that. But we'll have a look at a few more. So the next one is going to be, say, new machine learning. And if you search for machine learning, you also have the classic. So remember, I mentioned classic. This is not the one. The one you want is this one on top. You can actually also have machine learning for IoT Edge. So if you have Azure IoT Edge, you can also have machine learning there, but I'm not going to talk about that today. By the way, yesterday you had a workshop on Azure IoT Edge. So just have a look at that one, which is going to be clearly much more interesting than the time I have available today to show you anything for that. But let's say you want to do create, and from here you also do the same thing. So you define the usual resource group, whatever you want. I do recommend that you have a different resource group if you are running Synapse Analytics, Databricks, Azure Machine Learning, etc. Have a different resource group for each. Don't put everything in the same one like I'm doing now. But the reason I do this is that at the end of the session, I'll just delete everything in one go, but don't do that. Okay, so anyway, let's say end the ML, and then they will actually create a storage account for you, but you can select one that already exists if you want to. I'm not going to do that now, but you could use something like that. And you also have things like the key vault. This is where you store keys for accessing things which are connection strings and public private keys, certificates, etc. You can store them in the key vault, and this is especially practical to guarantee security. You also have things like application insights, which is when you deploy a web service to do the predictions, you might want to get some insights into what's actually happening. And this is the same application insights that you use for websites, so that you can get information, better information about what's actually happening in the website. So you can do the same thing for web services as well. Container registry is where you store the images of all of the containers that you want to create. So remember, an image for a container is basically the code that you put inside of a container, and the container itself is the implementation of that image in the physical world. Okay, so it's the same as having a class and then instance of a class in a programming language, right? But anyway, the container registry by default doesn't have any, but you can create one here, or you can use one that you already have, so that you can store this here, and this will work outside of the world of Azure Machine Learning, so that you can deploy this directly using Kubernetes services or using Azure Container Instances, something like that. Anyway, once you do this, you say networking. And again, let's assume public endpoints. Let's not talk about security today. Advanced is all about encryption and things like that. Let's ignore that part for today as well. And then you can just say review and create, and then say the create button here. And then once you do that, we can go down here to Azure, to the ML, to the machine learning workspace. To do that, you press here and you press launch in Studio. And I have this here. So I already have this using the Azure Machine Learning Studio. So let's go to my home. This is where I start. And this is one, but you might have more than one. So if you go here, there's actually a button behind me. There's actually a button here that you can change to a different machine learning workspace if you have more than one. For instance, one of the things I usually don't recommend is that you go to ml.azure.com directly. It's much better to have the full address so that you don't have to manually specify which one you want. It jumps directly into that one. And in this case, you can see that actually you can't see it, but it is here. It's the same as here. You can see that the address is a very long name that specifies a lot of details for this. By the way, you also have the JSON, the config.json file, where you store the configuration needed to access machine learning here. If you install this on your own computer or in a generic VM that's not inside Machine Learning Studio, in that case, you need to use that config.json information, or just configure it manually anyway, so that you can access the workspace and do things inside of the workspace. But I'll ignore that one for now. okay? And we'll try to see some things with Azure Machine Learning. So first things first, this is the Azure Machine Learning service or workspace, whatever you want to call it. This is what they call the ml.azure.com is what they call the ML Studio, the Machine Learning Studio. And you have things like the Designer, which is similar to the old version of the Studio, but we'll start from the bottom. So I've already run a lot of experiments. Some of these take more than 1 hour to run, so I was not going to run this in real time with you here. It wouldn't make any sense. But let's start with compute. So with compute, I've created a virtual machine, which is what they call a compute instance or a compute VM in the old name that it had. So you can just go here and say create a new one, and then you can say if it is CPU based or GPU based. So if you want GPU, it's of course more expensive, but at the same time it's great for machine learning in some algorithms. And then you can see all of the some of the recommended ones or all of the ones that you have here. And remember that the cost here is very similar to the cost, or is similar or equal to the cost of generic virtual machines that you have in Azure. So if you want to deploy a normal virtual machine in Azure, this would be the same type of costs. But then just specify one here. It doesn't really matter what it is. And then you just say next and then give it a name. So, and the compute VM, let's say, I'm not sure what the number is up to, let's say 5. And then you can enable SSH if you want to access it like that. You can put it inside of a virtual network security, and you can even give it to a specific user, which is not you. This machine learning studio does not need to be handled just for you. It can be handled for more people, so you can assign this to someone else. And then you can just say create, and that's going to create the machine somewhere here. Once the machine is created, you have a lot of options. So you can use the Jupyter Lab, you can use Jupyter Notebooks, and these are external things. So you jump into a separate page, which has the address of the actual VM. You jump into a separate page here. I'm not going to do that here because I'm going to use the notebooks inside of the studio. But if you want to, you could actually use these here if you'd like. So it's asking me for a lot of questions. So you can see I have my Compute VM1, but then I have my Jupyter notebooks here. I can have a Jupyter Lab. I could also have an R Studio, or I can even go to a terminal. So the terminal would be the same as a new terminal here. And inside of that VM, I can just play around with that location and see what's there. And have my users and things like that, which is similar to my users here. So I can play around with this. But I don't want to do this here. I want to do this in the studio, although you can use it there if you want to. But I'll do everything here in these notebooks just for easiness. But you can put this anywhere. You can put this on a Git repository anywhere you want, and then you can call this from your own computer. You don't have to have an actual virtual machine, by the way. Here, you can use your own computer for this, but it's practical if you don't want to install things on your own computer. Anyway, let's have a look at compute clusters, and this is where you would do a lot of processing. So first of all, notebooks are always run in the compute instances or in the compute VMs, but then if you ask for some machine learning training to be deployed in a cluster, this will actually deploy to a cluster which can be very big. And in this case, I've created 2 clusters. This was created automatically with one of the examples that I ran, but anyway, and then you have the other cluster. If I do refresh, I get the up-to-date information. This is not well refreshed at this moment, still creating. You also have inference clusters, which is basically you can create a Kubernetes cluster here so that you can put containers inside and then create web services to run the predictions. You also have the possibility of attaching other things like Databricks, generic virtual machines, and even HDInsight. You can associate those with Azure Machine Learning. In the future, I'm assuming that they will also add things like Synapse Analytics to the mix here, but currently this is all we have. So we've created the compute. We also have data stores, so this is where we get the information. You can get this from blob storage accounts like the ones you see here. So these are global data sets. And these are generic ones that I've connected to, but these 2 here are personally mine. And because these are mine, I can store things inside. One of them is just normal blob storage. The other one is a file share, like the file share you have typically on premises, where you have a file share server, and then you / server name / name of share / then you get the files, and then you map them as drive Z or something on your computer. So these are great for you to use and share with containers. Whenever you have containers that need to access files, this is the best way to do it with file shares. But in any case, these are mounted automatically. I've also mounted a SQL database, but let me show you how to do that. So you have a wizard here for a new data store. Remember, a data store is basically a data source. Okay, it doesn't have to be a specific table, but you have a data store which can be a SQL something, and then you can define that you want to get this from a Postgres, MySQL, SQL database, and this can be a normal SQL database, or this can be a SQL data warehouse if you want to. And then from here, you can just go to the server and try to find, this is a data warehouse one, the one below this, and the one on top is just a normal database. So dedicated one is a data warehouse, and then authentication type, SQL authentication, user. By the way, let me just actually give it a name. Dedicated, okay, dedicated one. And then password, this is my problem now. Okay. Okay, create, this is a temporary password, create. Okay, so I have my dedicated one here. I can change the passwords and things like that if I want to, that's fine. But then this is some of the parts. Data labeling is all about guaranteeing that you have labels for sensitive information, etc. Then you have your notebooks. So here you can create as many notebooks as you want. Let me just go to the data sets first. There's something that I want to show you before we move on to notebooks and these. And in this case, I have a few registered data sets already. But let's say I want to create a data set, and in this case I want to get it from either a local file, this can be a CSV file, Parquet file, etc. I can get this from a web address, so you get the information coming in from web, or you can use the open data sets which are available as examples. So some of these examples are easy to just use and try, but if you want to get it from your own data, let's say that you have the some table. I'm not sure what the name of the table is. I think it's orders or something like that, but I'm not really sure. And then you can get this from the dedicated pool that I've created before. And then because I don't know what it is, let me just go to my dedicated pool. I'll probably need to do a refresh here. Give me a second. Refresh. So I have my dedicated, and this is a very weird name. So let's just say I want to copy this. I'm going to be very lazy and copy this. Okay. Let me just copy this part. Otherwise, this is going to be, this is from the AdventureWorks database somewhere. These are order details from the AdventureWorks. The content itself doesn't really matter, so please don't worry. It's just something that I need to get, okay? So select star from this, you select okay. Oh, weird, select, okay. Select star from this one, let's say next. Hopefully this is okay. And as long as this reads something, I'm happy, so next. And remember that validation is important, because in some cases validation might require you to detect the types, if these are integers, etc. Because this is a SQL database, this is much easier to detect. But if this was a CSV file, you would have to define and guarantee that this is correct. So anyway, you go to here, you say create, and then you have your data sets being available here. So some database is here, or some table in this case. I also got the customer from my AdventureWorks database, and this is my AdventureWorks here that I have on a SQL database, completely different. So tables, I have my customer table here, okay? So I've used that one specifically. And of course, I have a few others that I'll show you in a bit. Okay, so I have my data sets already. First of all, let's try AutoML. So let's say new automated ML run. And then from here, I can just take one of the tables that I've created. But if you go here to create from dataset, or from open datasets, in this case, I've actually created one from sample diabetes. Okay, so I can just say next. I've created one already, but let's call it diabetes 2, okay, and let's say next. So this is 1, this is 2, that's fine, don't worry. Okay, I'll use 1 just in case. the two is going to have the exact same results. And then from here, you need to create a new experiment. So let's say diabetes experiment, but number 2, and then target column is going to be the column that you want to predict. So here it is a bit on the left. So it's a drop-down list, but it looks on the left here. So you have age, sex, etc., BMI, which are all medical metrics. And then the Y is apparently the one I want to calculate. I'm not an expert in diabetes, I have to say. Anything medical is not really my area. But in any case, the Y is apparently the column that we need to calculate based on the previous ones. Makes sense, has a nice name. Anyway, select compute cluster, and I can define one of the clusters that I want. This cluster is probably going to be the best one. It's probably going to be the one that's alive at this moment. I had to keep it alive, so experiment name. I actually had some name. Wait a minute. Okay, diabetes experiment 2. Okay. And then from here, you can define if you want classification or if you want regression. Now, Y is a sequential number. It's a continuous number. So that's the one I want. You have more additional information for featurization. Specify if you just want to see X number of columns. So if you don't want to use all of them, feature type auto. If you want to detect impute widths, in each of these details for this. I'm not going to go into a lot of details, but you can go into a lot of details for this part here if you want to when you do this. And then, of course, you have additional configuration, primary metric that you want to find. Spearman correlation is usually one of the typical ones. Although in some cases, root mean squared error might be something that you want. In this case, the second one, you want the lowest value possible. In this one, you want the highest value possible. Anyway, some blocked algorithms you don't want to use, so you can remove some of these from the lists because you've tried this in the past. You know they're not going to work, so you're not going to waste any time. Exit criteria, so maximum number of hours. This is crazy, but we can say 1 hour. Thresholds, we can say value, validation, etc. So all of these configurations you can do, and then you can just say finish, and then that will run the ML run. I'm not going to wait for this. I already have one that was created before. Otherwise, we would stay here for a long time. But in any case, we'll see the result of one now. So we can go to experiments, and then I have my diabetes experiment number 1, which is the results. And this actually ran, so run number 1 is done. The duration 1 hour about, and then the best one is going to be this one with root mean squared error of 40 or 0.40. R2 score 48, so that's fine. But you can say include child run. So in this case, you're going to see a lot of different algorithms that were used for all of these runs. And the best one, according to these metrics, is going to be this one. It's going to be this one. So this one was the selected one. And this actually took only 2 minutes, but the rest of the training took a lot more time. For all of these, you can add some charts that show all of these values for all of the things. So let's say add charts. So chart title something. Iteration is going to be here, and then mean root squared error, and then predicted. I don't know. I'm adding values here. I'm not an expert in diabetes, so I'm not sure which one is which. Okay, so you can just say save. And in this case, I'm only seeing, I'm not seeing anything now, so hopefully I will be able to see more at this moment. Okay, no selected rows, but for some reason it's not showing you. 1 minute. Okay. So you should be able to see some of the values. As long as you select them, you should be able to see some of the values here in terms of graphic, and then decide which ones you want. You can save this view at any time so that you can use this in the future. Also, if you go inside of each run, and let's take the one that was the best. So let's take this view here. Let's ignore this one, okay? Let's take this view. And then from here, let's have a look at some of the other values. So you can have all of the metrics here. And yes, you can do graphics with all of the metrics for all of the runs. But you have all of the information that you need here. And then, of course, you have the result model which is going to be this one, and then the model will eventually show up here in the list of models. Okay, you have some. If it is the case, you have some explanations for this, so that you can understand why values show up in this way or not. This is too much detail for this session. You also have the possibility of viewing all of the metrics in detail here. The outputs and logs are all of the text logs that were generated during the training. So there's all of these are physically in the storage accounts, so you can see them directly, or you can go to the portal and see it from here. If you want to use Python, you can also use the SDK of Python to call on these logs as well in a programming way. So it's also fairly easy. Anyway, you also have, if you had images, there's no generated images from this. Child runs, this is already the child, so this has one child run. Curious. And then of course you can have some snapshots of this to see some code that was used to do all of this, etc. And you can manipulate this and change this around anytime you want. So this is also practical for you to optimize things in the future. Anyway, once you do this, you can go to the models, and you should be able, by the way, I didn't do this, but I could go here to the model list and save this in this model list and say, this is the best one. Let's save this around and then use this one in the future, so that I can do a web service for prediction based on this. And to do this, you would generate something which was an endpoint. And in this case, these two are web services, which are gonna you can call a web service, give it some value, and get a prediction back. But we'll see that just in a few seconds. Okay, so the automated ML runs like this. You get the model out. This one is completed. This one is still running. You can see the experiments while they are running at any time. So diabetes experiment 2, you can see that this is still running. So it's still running. You can include the child runs to see which ones are running. It's still in a very early stage, so this is normal. But then it will be faster later on. But in any case, I only have one node per cluster, so this is going to run one at a time. So it's going to be slow, at least on this cluster specifically. Anyway, once you do this, you can also go to a different one, which is the designer. So this one is also done in a fully graphical way if you want to, and then we'll talk about the code. So an example of this, I already have one here, but at any time, let me show you one. Let's say a regression for automotive price value. So you want to detect the price of cars based on their age and things like that. And one of the things you immediately get here, besides of course these things, which I'll show you just in a bit. Give me a second, okay? But besides these things, one of the things you also have here is the settings. So if you click somewhere in the background and then press this button here, okay? You get select a compute target. You need to specify which compute target you want to run this in, okay? And you do a CPU cluster, you do something like that, whatever you want. And then for each of the boxes, you can actually have separate different compute clusters for each if you really want to. So you can parallelize processing in some of these pipelines. Now, the pipeline itself is very easy, and this is how you do machine learning. So this is something that I wanted to explain to you. So first of all, you get your data. So right-click, visualize, get the data set outputs. Okay, so you have a table with a lot of values. So name of car, type of fuel, etc. And then you have wheelbase. So I'm assuming this is size and things like that. And then somewhere you have a price. So the price column is the one you're going to estimate, right? And all of these are things that already exist. So you have a lot of 200 rows, not a lot, but still enough to get an example. But then from here, you can go here, and then this one and this one, you're actually limiting all of the things that you are seeing so that you can do some ETL, some cleanups, etc. So you clean up things. And then from that point on, you do something which is very typical in machine learning, which is you take your data sets and you divide the data set into two parts. In this case, 70% is going to be for training and 30% is going to be for the prediction part, for the testing part. Now, what you do here is you have a box that says train, and that box is actually attached to the type of algorithm that you're going to use. And this can be, for instance, you have machine learning algorithms, you have quite a lot, regression, clustering, etc. So you can choose which one you want, drag it to here, here, and then connects the line all the way from here to here if you want to. This is not going to work because it's already something there, but let's assume that it did. Okay, so you can specify which model is going to be used for training. And this train model here is basically a butler. It's like someone that receives the information and then processes the information based on that algorithm and based on that amount of data that you receive. So anyway, once you train it, the result is going to be a model. Okay, this is going to be the result model, and that model is very simple. You send that to the score model, and the score model is actually the one that takes the model and tries to do predictions with values, and these values are the remaining 30% of values that you have here. So this is very simple, and then from here you take that information and you get the result coming out. And at this time I cannot see the output because I would need to run this, so I would need to press this blue button here, which is run. It's actually closed here, but this one, to actually see it. But to do that, I'm actually going to go into some of the other ones which are created already. So let me just say which one it is. Okay, so it's this one down here. So this is very simple. You have the same logic, although with a bit more columns. Okay, but this is completed, so I can just go here to my score model here and see the results. So view, by the way, the output that comes in is the adult census income binary classification. So basically this is very similar values to the one you would expect for the bank loan, but the result is how much money the person receives at the end of the year. But the result here is going to be visualized score data sets. So the result is you have some columns in the beginning, which are all of the columns you would expect. But then this is the column that you want to predict, the income column. But then these two new columns are the ones that are generated in the score box. Okay, so in most cases this is going to be similar, but there are some cases where this is going to be wrong. So this one, they got wrong. So minus 50, more than 50,000, dollars per month, per year that they receive, less than 50,000. So this is the value that was wrongly calculated in this one as well. But you can see the probability itself. And this one is closer to the 50% threshold, but this one is just strange. So this person, you might want to have a look at why this person is very strange. But in this case, there isn't that much information here to begin with. That's okay. Well, high school, something, that might be the reason. But anyway, but they do have an income bigger than the average that was calculated. So you can see all of this, and then you can go to the evaluate model box and see the evaluation results in a graphical way. You can also do this in Python, by the way, but you have curves. So the ideal curve would be closer to the one that you see here, but this is not perfect. But here you have the threshold of 50%, and here you have something that's called confusion matrix. In this case, it's only 2 by 2 because you have the actual values of less than 50,000 or bigger than 50,000, or A and B if you want to, and then you have the predicted of this. And the correct values are going to be the diagonal. So the 11,000 and the 2,000 are correct. Now, if I move the thresholds to here, and the correct value for this algorithm is going to be around 60-something%, by the way. This is going to be more optimized in terms of accuracy. The best accuracy is going to be somewhere. So if you go here, it's up to almost 85 here if it is 59. But let's say you go to the extreme. So there's no, or close to the extreme anyway. So there's going to be some values here that are predicted over 50,000, but it's only 1% range, so it's not going to be a lot. So most of these 3,000 are going to be wrong. If you do it the other way around, all of these that are the blue ones, big blue here, are going to be the wrong ones as well, because only the diagonal is correct. But anyway, somewhere in the middle, in this case it's about 60%, 50-something%. That's going to have the best ratio here of rights and wrongs. But anyway, we'll see a few of these also later on in a bit. Okay, so anyway, you get this. You can do this all graphically. Once you are happy with this, you can just click the publish button, and the publish button will generate this real-time inferencing pipeline. So what is this? Well, it's the same as the previous one, but they've added web service output here and web service input somewhere here, and that means that instead of getting the data coming in from the actual data sets, you are getting the information coming in from a web service, and then you deploy the whole thing. So you test this, make sure it's okay, and then you can just click a button that should show up here later on. Well, actually, it's here. It's the deploy button, or publish in some Azure services. It's actually deploy in here, so you can deploy this into a web service. Okay, so I started the session. I pressed the deploy button just as I was about to start the session. I have no idea if this is there, but apparently it isn't. So let's say refresh. I don't think it is. I don't think I pressed it. It wasn't there when I pressed it, apparently, so it's my fault. But if you press deploy, you will get a web service here in the endpoints, or is it here? Oh, it's actually here. Sorry, it's actually this one. My fault. So it's actually here. So you can actually say tests. So you can test the age, etc. So you can say tests. This is the one, and then the result is going to be bigger than 50,000 or less than 50,000 here. But if you try to get this wrong, and I'm going to be very sneaky about this, I'm going to try to get this wrong, and I'm going to say capital gain of a lot of different values, because I know how to fake this, I know how to hack this. If I say tests, in that case, it's always going to be 99%. Okay, I know this because I know the data, so I can play around with this. But you can test this. This is going to go into the web service itself, and the web service is going to be a JSON file, so the result is going to look something like this. Okay, it's just as simple as this. And then from your own applications, you can consume this from your own applications. And to do that, you know which address it is. You can use tokens or keys, etc. So you can do this. And you even have code which is in C#, Python, and R as an example for you to deploy all of this. So you can see. Let's try C#. So you can see that to actually call on this, first of all, you need to create a class. This is very simple, by the way. You need to create a class that has all of the initial values, so that's easy. And then you apply that and you send that to a requests, which is basically just say post sync of the actual requests. And that request which will be HTTP something. I'm not sure what the address is going to be, but it's going to be somewhere here in the configuration. Here, .westeurope.azurecontainer.io/score, and this web service will run everything for you. And then you have an API key which you need to know, etc., etc. So this is still fairly easy to do. Okay, and then the result is going to be, if result is okay, you then need to parse the JSON result that comes out. If it is not okay, you get an error message, and you parse the JSON as the error message. So also very simple to do. This, as I mentioned, is all done in the designer. So this is all automatic in graphical terms. So you don't have to do any code except in the actual application that you run. Okay, so this is very simple. I usually put this kind of thing inside of a library, inside of a DLL, if you want to call it like that, so that I can call on this from my application, but also from other places. But you can call on this directly from REST APIs, but you also have some SDKs that call on this in a class format if you want to. Okay, but this is easy enough. Anyway, you also have some notebooks, and this is the last part that I want to show you inside machine learning, and I still have to show you Synapse Analytics, okay, and cognitive services. By the way, with cognitive services, what you get when you have the designer, so when we saw the designer, the endpoints there, when we saw those endpoints with that code, etc., this is going to be very similar to what you have in cognitive services, okay? So we'll see how to do this. Now, first of all, you have notebooks. By the way, when you start notebooks, it usually looks like this. So it's kind of hidden. Okay, so what you have to do is to expand this, because people usually don't notice it's there. Okay, so you expand this and you go to sample notebooks. The other one should be empty. And then you have some samples. Currently, it's version 1.19. There are some bugs between version 1.19 and version 1.18, at least in terms of Python, so please be careful. You can still use 1.18, but you have to go into the virtual machine and change the version of Python. So there's an explanation on how to do that on GitHub. If you go to the DP100 course for machine learning on the Microsoft Learning GitHub, and they will actually explain how to do that. But anyways, you have some how to use Azure ML, some examples of AutoML but using codes. You have a lot of this. I will show you a few of this which are interesting. Create first ML experiment. Try this. interesting. Get started, etc. Quick start as well. And then you have regression for New York City taxi. This one is especially good for doing the preparation, the ETL, before you do the machine learning. They have a lot of ways to do that, so you can learn from it. And if you want to get it, you can just go here and say clone, okay, to the whole directory. Don't do this file by file, just do the whole directory, and then I can clone this here, and this shows up there. I'll also have the image classification. I've cloned this before already, and that's the one I'm going to use. I've processed this already, took an hour and something. So this is actually cloning this one, so that's fine. So when you go here to your files, you have the regression, which is new, but I will actually use the image classification MNIST database. And the MNIST database is a database of handwritten digits, which were about 70,000 handwritten digits between 0 and 9, so that you can do character recognition, OCR, with this training. So I'm going to do this. By the way, I'm going to move this, hide this again, if that's okay. I'm going to hide this because otherwise we'll not be able to see this. Okay, but I will hide this here. So let's go to image classification, and then I have a tutorial. So let me just explain how this works. This uses Python, and this uses machine learning with Python, but it also uses a lot of calls to the SDK and to the machine learning workspace itself. Now, to get started, the first thing you need to do is you need to run this. So you can just click this and say run. I've done this before, so it took X number of minutes, something like an hour, something like that, to run this one and the next one. The first one just does the training, the second one deploys the web service, okay? So we'll see that in a second. So the first part is you import a whole bunch of things. This is normal, and then you check if you have the Azure ML core, which is the library that you need to do to interact with Azure. In this case, you get 1.19, which is the current version. That's fine. 1.18 seems to be more stable with the current version of Python, but I'm not going to go into that at this moment. And then you can get the workspace from config. Remember, I mentioned there's a config.json file that needs to be put in the same directory as these files, or a parent directory, so that the SDK will try to find where it needs to connect to. Otherwise, you have to do this manually and write workspace parentheses and then specify all of these parameters. So like the name of the workspace, the region, and then the resource group, and you have the information, and then here you start to do the actual work. So first of all, and this is the same if you already used Python, this is not going to be that much different from other technologies, but because this is inside the SDK, it might look stranger in one or two things. So the first thing you need to do is you create, you get a name for the experiment, let's call it like this, but then you import the experiments, the experiment classes, and then you create a new experiment. So experiment is equal to the new experiments in that workspace that we had before, that we connected to, and then give it that name which is there. So you can just give it a name directly, but in this case it's like this. So once you create it, you can just go here and create a compute cluster. Okay, so the compute cluster is going to be named CPU cluster. This is why you saw something in the compute here that was named CPU cluster. If you already have one cluster with a different name, just put the name there, and it's easy enough. And then it has a maximum of number of nodes, etc., size, and all of those things. So if you already have that target, it just says found the target and uses the one you have here. If it doesn't find it, it will try to provision a new cluster. And this is the magic of the SDK, because the SDK can just create a new cluster just by doing this. This is all it needs. You can just say, this is the configuration, number of nodes, size, and then you can just say, please create a new one. This is the name of the compute, and this is the configuration. 2 lines of code just to do this, just very simple. So you can create a new cluster. In my case, because that name did not exist, that CPU cluster name did not exist, it actually tried to create a new cluster. It took a bit of time, so I'm not sure how much, but it did take a bit of time. There is going to be new things which are available soon, which allow you to see how much time each of these took to execute, but let's not go there now. I don't have that running here. Anyway, once you do this, you need to download all of the databases for the MNIST database. This is an open source database. By the way, And you can download this from the Azure ML open data sets, or you can just get a file from a storage or something like that. Doesn't really matter. So you are getting the data sets. So these are 3 files. By the way, there's file data sets and there is tabular data sets. Tabular data set is just a table. A file data set is a list of files, and then you have to go to each file and then load each file individually. In this case, it's a get file data set, so it's a list of files, at least 4, as far as I remember. And then all you have to do is to get that file data set to be registered as a data set here. So let's see if this is here, data sets. So I'm not sure if this is here. MNIST open data set, so you have them here, etc. Okay, so designer, let's go, notebooks, let's go to the notebooks again. And from here, you get that information coming in from here. Actually, sorry, not here. It should be in the data store for all purposes, but that's okay. Okay, please ignore that. Okay, so anyway, once you do that, you need to get the actual files, and this is going to get all of the files coming in, and the xtrain, xtest, ytrain, ytest, etc. So you have all of the information. For the X train. The X train is going to be the actual images, the pixels of the images, and the Y train is going to be the labels of the images. So these labels, by the way, you can see them down here. So on top you have the Y, which is the real number that corresponds to the correct value that the human verified, and down there you have the pixels for each of these images. And of course you have the train, which are the 2, and then you have the test. The tests are just a smaller amount. These are 70,000 in total. The first 60,000 are for training. The other ones, the 10,000 extra, are for testing. But you can just bundle all of these together and randomly select if you want to. It's up to you. But in any case, this is the example you have. So all of this part here, I'm not going to go into details about the code, but this code is literally just to show you this graphical image, okay? Just to plot this graphical image using the plots options here. You can see all of this from here, and this was going to be practical in the future. Now, once you do this, and you have the information coming in, you need to train machine learning to recognize all of these images as the correct label that you see on top. And you see 6 is equal to 6, 1 is a very weird 1, etc. So you have weird numbers, and this one just looks a 6 that looks a bit weird. This one I have no idea what it looks like, but apparently it's a 2. This one looks like a Greek symbol, apparently, so that's weird. Anyway, you need to do the training itself. So the training is actually much simpler to do. You can just go here. Once you do all of the ETL, you can just say, look, I want to do this using training in a specific cluster. So to do that, you need to create some directories for scripting and things like that will be sent to the new cluster once you deploy that training to a different cluster than the cluster running this notebook. Now, the next part is that you have the write file directive here, which is going to say that everything inside of this cell is going to be written to a file inside of that script folder called training.py. This is typical here inside of notebooks. And so basically you do a lot of importing. You get all of the files coming in again. So all of the things that you tested before, you get them coming in again because you are doing this in a different server. So you don't have the previous variables as you had there before. You do some printings to see some results. And then you use something called the run. Run is a variable that gets you a context into the Azure Machine Learning Studio, so that you can interact and send information about all of the metrics that I've used for the graphic that you saw before, like accuracy and things like that. So you can get log.run and then specify variable name and then variable value. It's very easy to do, but then the actual machine learning is very simple. The machine learning is just this, okay? This is just a part for machine learning using logistic regression based on the information coming in, and then you say fits, and then you do the training and the Y training. So this is the images, the Y are the labels, you do the training, and then you take the results and then you do the testing. Now you do the testing with the X tests, which are the images. You are supposed to get Y labels for the testing, and then you compare these two, and this is the comparison to find out the accuracy. You compare this with the Y results that you got with the Y test results, which are the original ones, and then you get the accuracy based on this. So as you can tell, this is just a few lines of code to do all of the things that we did before graphically, but with 4 or 5 lines of code. This is all the machine learning part. All of the rest is just scaffolding so that you can run the machine learning itself. But the machine learning part is the blue stuff that I have selected now. So it's very simple. Anyway, once you do this, you have you can create directories for outputs, etc. Dump the model. And by the way, this is the model file that you have here. This is the actual model file. But remember that here I'm only writing that's Python script as a whole. I'm not really executing it. So how do I execute it? Well, you need to go down. And by the way, this one just adds a utils.py, a library, so that you can process the images into the pixels into whatever kind of processing that they need to add to the machine learning. But for here, now I have the actual creation of the cluster. Now to do that, I can create an environment, or in this case, I'm trying to create an environment called tutorial env, or if I already have one, that might be the case. Conda dependencies are all of the dependencies management that you need to have inside of your cluster when you run it. So in this case, you want to run the Azure ML dataset runtime with pandas and fuse libraries, and then you have the Azure ML defaults, which are libraries that you also need to have running in there. And then the conda packages, I also want to install the conda packages of scikit-learn, which is actually the scikit-learn is actually the library that runs all of that machine learning. So this one that you see here, the logistic regression that you see here, actually comes from scikit-learn linear model logistic regression. Okay, this is actually coming in from there. Okay, so once you have this, you define the dependencies, you register that as an environment. It's up to you. You can register or not, although there's no graphical way to see the environments. You can just go to the environment variable here, go to workspace.environments or something like that and see all of the environments available. But in any case, this is the results of all of the environments that you created. Okay, some of the things are already created for you automatically, so you don't have to do anything. Then you need to create the actual parameters. Okay, so you are creating parameters like data folder, which is going to be a location on the actual server, and it's going to be the one that you created before. Regularization, which is going to be a parameter 0.5, but it can be between 0 and 1, something like that, depends on you. And then you are going to do a script run config, in which you do this is the script folder, this is the file that you need to start with, the train.py file that we created, and then you have arguments, which are whatever arguments you need to run, and then compute target is going to be the compute target we had before, and then the environment is going to be the environment we had before. Once you run this, you are actually creating the cluster itself and running things in the cluster. Actually, the cluster is created, but you are deploying to the cluster. Okay, so once you do this, the job is actually running. So if you go to the run object, this is asynchronous, you can actually see the things running at the same time. So if you go here to link to Azure Machine Learning Studio, that links to one of those things that we saw for these experiments here, where we saw all of the runs and all of the graphics, etc. And you can define what things you want to see in the graphics. Remember these images that we had here before? If you want to, you can even send these kind of images here, so that they get registered along with the experiments, so that you can see as results whenever things go along. But anyway, once you do this, you run the experiment. This is the part that takes a lot of time. It says 10 minutes. It's going to be more because the cluster is not going to be the same one. But once you do that, you can even use something which is the Azure ML widgets. There is something called run details that actually cycles in real time to see this in a graphical way, so it's very practical to see things as they go along. But if you want to, we can always go to view run details and jump to the to this experiments area here so that you can see things from there. That's all perfectly normal. Anyway, once you do this, you can just say wait for completion. So that means it freezes your notebook until it completes, but then again it shows the output here as well. So once again you can see that this is all that was run from here, and this is a lot, by the way. Downloading things, running something, and this is doing something. Okay, I'm not going to go into a lot of details what it actually did, but it's machine learning inside. Then you have run.getMetric, so you get the metric, and in this case you have an accuracy of 91%. That's a good metric. Regularization rate we configured at 0.5, but the accuracy was 91, almost 92%. And then you need to register the model, so you can get the file names, and you find out that you have a file called sklearn.pkl. And for that file, all you have to do is to say run.register model, and that is associated with that experiment, and with that immediately goes into that model list here. So you basically give it the name of a model, you give it the path, which is going to be this one, and then you can just say whatever name, the ID that you can add if you want to, and this is going to be the result that comes out. So in this case, model name is the scikit-learn MNIST that you see here. The ID version is the version ID. Okay, sequential ID. In this case, it's 1, and the version is 1. So the model.id is the name plus the version. So these two together with the 2 dots in the middle. Okay, but if you go here, sklearn MNIST, if you go here to models, you'll actually be able to see that you have skm MNIST version 1 and version 2. Version 2 is for the next script I'll show you. They actually repeat the registration of the model. It's redundant, but it's okay. But if you go here, you have the information about the model. So you can add your own tags. This one actually doesn't have the tags, but this one does. So you have the MNIST, you have model classification, you can add whatever you want, and then you can have details for the actual image. Endpoints are the endpoints that are created that show up here. These are web services that are running at this moment, that are using this model at this moment in Azure container instances. So these are individual containers running. These are not Kubernetes. And then you have explanation, fairness. We talked about fairness and ethics. You can also see things here. And then if you have data sets associated with this, you can actually see them. Although for here you don't, but if you have data sets from here, you will actually be able to see them here associated. And this is great because they connect to each other. These are all connected, so it's very easy to manage these things because they're all connected. Anyway, getting back to the notebook, so this is the first part. The second part is to just deploy the thing. Okay, so tutorial to deploy model. So we go here to files again, and the second one is deploy. You also have deploy with encrypted, so you can guarantee that you have encrypted inference. So you have an encrypted inference server, but I'm not going to go into that. It's very interesting, but I'll leave that up for you for homework. But let's go into the second one. Okay, this is the second one for deploy. So deploy is easy. So the first part is always the same. So you get workspace from config, usual stuff. They registered the model again, and you can see that you have the tags that we saw just before here. They are just 2 minutes ago. The tags are here. What I usually recommend adding to the tags is things like the values, the metrics, etc. These are good to actually write here. But then description and tags are entirely up to you. They are useless for the computer. They're just for human consumption. Okay, technically you can find things by tags and things like that programmatically, but these are for human consumption. Anyway, once you do this, you also get an environment, and in this case you get an environment, but this time for a container, not a cluster, not a virtual machine. And then you do the exact same thing. So you register that environment. Once you do that, and of course you have that specific version. Again, you need to deploy that as a web service. To do that, you create a score.py file. First of all, you're just writing the file, not really executing anything. And the file has two parts. It has the init part, which is every time you start the container or the web service, you are actually initting that. And that means that you are getting the model from somewhere, which is a file somewhere there in the container. And then you are loading that model into a model variable. And then every time someone calls that web service, you run the run function, and the raw data is going to be JSON content, XML, whatever you want. It's your processing, so it's your problem. It can be raw data, binary even if you want to, but let's say it's a JSON content, and then you can just get all of that content coming in here into the data, process data, using JSON libraries to process the content. And then from here you can just say model.predict, the same model on this global variable, and from here that's very easy. You get the Y results, and then the Y result, you can just send the Y result back directly to the user, and it says .toList, so it's going to show up as a list, the JSON list, so it's very easy for the user to consume this in an application. Now here you can just also create a configuration file so that you define the image for the container. So this is the definition of the container. In this case, I'm using an ACI, Azure Container Instances, which is a single container floating around in the cloud. However, if you were using this as a Kubernetes, this would be similar. Instead of ACI, it would be AKS and then something. But in this case, let's say ACI, number of cores, number of memory. Tags and description are completely human parameters, not useful for the service itself. And then you deploy the thing. So here it took about 2 minutes of wall time. So this was actually fast because they ran the time directive here. But then what they do is they go to the workspace, they get the model from the workspace, and in this case, because you don't specify a version, you get the latest version. So this was version 2 already, and then you get the environment, and then you create a new inference configuration for the container, and then you use the score.py file we just created as a starting point, etc. You can also define its Python. You can define all of the parameters up there in the conda configuration that we saw before, but this is very simple. So anyway, once you do that, you give it some weird name for the service. This is a random, well, not random, but it's from a human perspective, this is going to be a random name, and then you can just say model.deploy, and this will deploy the cluster. Sorry, not the cluster, the container. This will deploy the container into that workspace using that name, using that model file that was here already. And this is just one model file. You can have more than one if you want to. The parentheses, the square brackets actually can put more than one model inside. And then of course you have inference configuration, which is this one from here, environment, etc. ACI configuration was somewhere from here. ACI configuration. So it's very easy. Once you do this, you stop the execution and wait here until everything is deployed. It took 2 minutes to deploy. That's fine. And then you have an address which you can use to run these services. And let me just go here. Just go here and run. Oh, this is already here. So you can see you have data. Something has gone wrong, of course, because there's no data. I will have to write it in JSON format. I have no idea how to write all of that in long text, so let's ignore that one for now. But let's come back to here. So here, once you have this, you can try to test this. So how do you test this? Well, you can send, you can get the MNIST database again. So this is the usual things, but then you can just say, load all of the images, etc., and then you try to predict them. But to do that, all you have to get is the results coming in. By the way, this is still not in the service. Wait a minute. This is still not in the service. This is still in the testing part. I think they swapped two for some reason. But anyway, oh no, this is actually service.run. So it's actually here. Sorry, it's actually not here. So it's still using the service variable that was there before. okay, to actually refer to the service. But if you don't have the service object, as long as you have the scoring URI, you will be fine with it. Okay, so it's the same thing. There's also an example for scoring URI somewhere down there. So first of all, you get the images, etc., and then you run those in the service by inputting the information that you want and getting the results out. This one actually tested with a lot of them as batch. So instead of just one or two, it actually outputted a lot of images. I'm assuming the 10,000 that were there, and then gets the 10,000 out as results. And this is the results that came out. So one of these is going to be the actual, the other one is going to be the predicted. I'm not sure which one is which, but the next one tells me. So this one is the true one, and this one is the predicted one. So similar to this one. So what's the difference between this one and the next one? These are the same. The diagonal here has all of the true values, which are the majority. So most of this is correct, 91% correct, which is here, which is okay. But to actually visualize it graphically, I'm going to do a lot of plotting here. But to do that, the first thing I do is to remove the diagonal so that the diagonal does not mask all of the remaining values, which are much less. So you blank the diagonal, and then you just talk about the remaining values. And the biggest errors you have is whenever you have a value that's actually supposed to be 5, and they predict the value was the number 3. It can happen, so I understand that the numbers can be very similar when you write them, etc. So we have number 8 compared to number 2, so we might have an 8 which is drawn that looks like number 2, something like that. But anyway, you can see this graphically. That's just an example of seeing that graphically. And then if you want to do that, as well, you can see the results. This is an example of seeing the results. And in this case, all the ones that are wrong show up as red. So reds, font color reds. And then this one that looked like it was predicted as a 3, but I have no idea what this is. It looks like a 6 the other way around, so I'm not sure what it is. This looks like a 5. It was predicted as an 8 and something like that. And this one as a 4. It was actually an 8. So because these were predicted wrong for some reason, they got detected here, and we see a few examples graphically. Now, the last part is just to show how you can call the URI directly, so the actual HTTP something, but then call on it using HTTP directly, HTTP headers. So basically using this as a REST API. So this is very easy to do as well. So in your application, you can call on one or you can call on the other. So this is either way, this is very easy. Okay, so simple enough. Anyway, this is the part that I want to show you about this. You also have, as I mentioned, the experiments. Pipelines are also very similar to the designer, so sequential things that you do. Endpoints are, of course, going to be the web services that you create as a result for this. And this is simple enough. This is Azure Machine Learning. Now, but next up we have Synapse Analytics. Now, Synapse Analytics is also very simple, and this one I'll show you very quickly. I still want to talk about cognitive services for a bit, but Synapse Analytics is also very simple. So you go to Synapse, okay, and then you say Synapse Analytics. Once you try to load this, you can just say create, and then the first thing you need to do is you need to specify, of course, here, and then you give it a resource group. I'm not going to do this now, but you give it a resource group. You give it a workspace name. I called it Andy Synapse or something like that. And then you need to create a data lake store account or just use one that already exists. And you also have to have a container inside of that storage account. In this case, it was already created, but you can create one if you want to. From this, you have to also define the security. So by the way, there's a SQL admin user. You should always change the name of this user, and then you have a password, and this is going to be used for these two over here. So inside of Synapse Analytics, you have a Synapse normal one, and you have a Synapse for the on-demand or the serverless version. So you have two. I'll show you the difference in a bit. But this is the password for both, and then you can change this at any time. Networking is the same thing we mentioned before, and then summary, you can just say create. Assuming, of course, that you validated things correctly, you can just say create. By the way, before going into Synapse Analytics, I just wanted to show you one more thing in the portal, which is to create an HDInsight cluster. I talked a lot about this, but I didn't show you how to do it. I'm not really going to create an HDInsight HDInsight cluster. In most cases, you're not going to use it anymore. You should use one of the other technologies that I mentioned. I would probably use Azure Machine Learning first, and then Synapse Analytics, and then Databricks in that order, because things changed in the last year or two. Things changed a lot. Now, when you create an HDInsight cluster, you have to define the cluster type. Now, the cluster type that you have here, you have an Hadoop cluster, which you can have a lot of different nodes and then store things, and you can do MapReduce, etc. You can use Spark as well, so Spark using HDInsight. You can have Kafka for real-time ingestion of data. You can also have Storm for ingestion of data as well. You can have the R server that I mentioned before, and you can have a NoSQL database here as HBase, or you can even run interactive query if you want to as well. So all of these are created using HDInsight clusters, but these are individual clusters. You have to create them separately every time, and you have to manage them separately. Once they are created, it's your problem. Okay. However, in the other ones, you can just create and destroy any number of compute virtual instances, and all of the rest stays there because this is cattle virtual machines. You can just destroy them at any time, and the data is not inside. The data is somewhere else. Okay, so it's much more practical to use. But now let's have a look at Synapse Analytics. Let's go to Home. Okay, I've created a few things already, and Synapse Analytics is basically also an interface which has a lot of possibilities that makes things like the integrates and the develop have things from Azure Data Factory, which is basically things that where you can do ETL and do data flows and things like that. So if you go to develop here, you can do data flows. I'm not going to show you that in this session. It's not the part of the session that I want to show you, but you can create data flows. If you configure it here, you can even add Power BI reports to the list here. But you can also run SQL scripts and notebooks. These are the ones we're going to look at this moment. But you can also have a lot more things in the gallery if you want to, and in the future this will also change. The integrate is the pipelines that you can create pipelines from, similar to the ones that you have in Azure Data Factory, so that you can orchestrate operations like ETL, etc. And these are very practical machine learning. If you need to prepare the information before feeding that to machine learning, instead of using notebooks, you can just use integrate here and do it from there directly. So this is an integrated environment, which is very practical. You can call from here. You can call Data Factory, you can call Databricks, you can call machine learning. All of these can interact with each other. It's very practical, but then you have to decide which technology you want to use. So try them out, see which one you want. On the management level here, you can create a few things like SQL pools. And SQL pools, you can create a dedicated SQL pool. Let's say create new. And these are SQL pools, which are data warehouses, basically. These are parallel processing data warehouse. So each database like this has 60 nodes, 60 nodes where information is divided, and then you can give it a name. So let's say dedicated 9. I'm not sure which number was the last. And then you can specify cost per hour. You can tell it's a bit expensive, but that's okay. Additional settings, blank database, or getting that from a backup as well. And then review create, and you can just say create. I'm not going to do that now. Okay, this card changes, but you have this here. You can also have databases which are serverless. So serverless databases do not store any data. They just store what they're called external tables. These are tables that actually connect to data in data lake and things like that. These are like links to those tables where you can just do SQL queries directly to those tables without actually being tables, without actually storing the data. The data is stored in the files. So it's basically a link or a mask that goes through the SQL engine that calls on that. But if you have a serverless engine, you cannot store tables. If you have a dedicated SQL pool, in that case, that database you can store tables. That's the big difference between the two. So on a dedicated one, you have tables. On a serverless one, you don't have tables. You only have, you have tables, but these are external. These are external tables. And this one, you can have external tables, but you can also have normal tables as well. Okay, so that's the big difference. Anyway, let's go back here and let's have a look at data. Okay. Oh, before that, sorry. Before that, so Apache Spark Pool. So you can create Apache Spark pools. To create them, this is easy, similar to the other one. So sizes, name, some additional settings, auto pause after X number of minutes, etc. And currently, I have let's say cancel. Currently, I have two ones, Spark 1 and Spark 2, which is okay. You also have linked services, and this can be connecting to a SQL database. So you can just go here to new, and then you can find a lot of information like Amazon. You have a lot of connectors. So all of the connectors you have in Azure Data Factory, you also have them here. So this is very interesting. And at the same time, you can just go, let's say you try to find the SQL, and in the SQL one, you can just find SQL database, MySQL, etc. If you are trying to find the SQL database, in that case, you can actually find that where your server names are. So I have 2 or 3 at this moment. Sorry, it's taking a bit of time. 1 second. It is taking a bit of time. SQL database, is that correct? SQL, Azure subscription, server name. Okay, server, Synapse. So you have my server. This is the normal server that I have here. So this is a normal server in the SQL database in the cloud that only has one database. It also has the master, but it has only one database with tables for AdventureWorks that was created in the Azure portal automatically. And then I've added a lot more tables there just to play around with. Anyway, then you specify the database name, AW for instance, and then you specify the authentication, etc., etc. So I've created that. Then you click here, test connection, and it should work. Okay, so this is fine. Let's say this card changes, and then from here you have SQL database, so you can see it from here if you want to. Okay, at any time change it, test the connection. Blob storage, I also have the possibility of connecting to blob storage, and in this case I will get my Andy blob storage. This is actually the name of the storage account. So you can continue from here, test connection, see if everything's okay. Should be, and then you can use files from inside blob storage. These two were already here when I started, so they are already there, but you can create as much as you want. You also have triggers so that you can run those pipelines automatically. You have a few other things like integration runtimes, which is every time you execute some things in those pipelines, you need to run this in a VM, and you can create integration runtimes to actually run those. But if you are just using the data part here or using Spark, you don't have to worry about that. Okay, so anyway, what do I have here? So please allow me to remove this part here on the right. Okay, and for here I have a whole bunch of databases. So the dedicated databases, I can also create plus and then say SQL database, and the SQL serverless databases you can create here. So serverless 8, whatever number it is. I'm just doing random numbers at this moment. Okay, so you can add them here. Serverless is actually quite quick. So external, currently empty, but I can add more if I wanted to, but I'm not going to do that at this moment. And then let's say dedicated 1. And this is physically with one table already. Okay, so here you can do the usual stuff, which is go here and say new SQL script, get top 100 rows. So this is very easy, of course. So you get all of the results. Let me just zoom this for a bit. And then, wait a minute. Okay, make this a bit bigger. 1 second, make this just a bit bigger, and then you have all of the information there. You can do a few other things, like if you want to open this instead of using a SQL script, you can create, drop, etc. That's obvious for a table. But if you want a new notebook to load this into a data frame so that you can use this in machine learning, you can also say, by the way, df mode something, and then display df. So you can run this. Hopefully this is okay. Oh, okay. So I have to select the Spark pool here, Spark pool 1. Of course, I'm here in the front, so I didn't really see this. Okay, but that's okay. So it runs. By the way, this will take a few minutes, so we will come back to this. Okay, so let me put myself here on this side at this moment. Okay, so that we can see things here. So language, in this case, it's Spark, a Spark Scala. But in theory, you can run this. This is very similar to Python in that sense. Anyway, for here, this is fairly simple. Okay, new notebook, you can even create a new data flow where the information starts from this table and then does some changes, etc. You can do a lot more, but let's say that I don't want to do this. I want to do something else. And in this case, I'm going to go to the linked ones here, and I can add a linked connect to external data. So in that case, a blob storage, like I mentioned before. So I do have blob storage, I do have data lakes, etc. So I have a blob storage, data lake. I can even add a Cosmos DB if I wanted to. So also very simple, just go there and say plus and then select. And in this one, I have blob storage for customers. So if you right click on this, you can say new notebook load into data frame, new data flow, integration dataset, download, etc. Please be careful because currently, this will change in the future, of course, but currently, if you handle the right click here in the blob storage or in the data lake, the results are actually slightly different, okay? Some of the features are available in one, they're not in the other, but hopefully in the future they will fix this so that everything is the same. So let's go to my data lake, and I have some files here, so order details. Actually, I'll start with the Parquet file. So if you have the Parquet file, you can say top 100 rows as well. And please notice that this one is actually being run on a SQL database, okay? Sorry, query canceled, my fault. This one is being run on a SQL database. It could be run on a notebook. That's typical for a Parquet file, but this one is actually being run on a SQL engine. And by the way, the SQL engine can be your built-in engine, which is serverless, or you can go to the dedicated pool if you want to. And then the actual database you can run on the serverless, the two ones that we created, or the master. Never run things in the master. That's just ugly. That's basic for anyone that knows SQL. Or you can run this in the dedicated pool if you want to. And in the dedicated pool, you have all of the capacity dedicated exclusively for you. But of course, you can have real tables instead of just references. By the way, those references are the same as Polybase. If you heard of Polybase, the references when you have external tables, those are basically Polybase. By the way, so the result here of opening this file from inside SQL is this one. So from here, you can actually say select into a table or something like that. So you can create tables from here. You can also use something which is create table as selects and then get that from there. So if I were to say something here on top, like create table, ABCDE or something as this will probably run. I'm missing some things here. I'm missing some content here, but you should be able to run these kind of tables with things look like this. So create table or select is something that you should try because it works really well. But anyway, I'll leave this up to you for homework. Let's try a few other things. So this one, let me just close this down. Close this card changes, and I was here in a notebook, if I'm not mistaken, and I was trying to display this, so there was an error. So for some reason it did not execute to get the information coming in from this. So I do apologize for this, but please bear in mind that it is perfectly possible for me to go here to the workspace and trying to find from here and actually see new notebook, load to data frame, or any of this. So I know that this works. By the way, one of the other things you are probably curious about is if you are using Spark. Spark, typically you can create tables inside of Spark, right? And you can send tables that are from here or from files and create a table in Spark, or you can go to Spark and say that I want to see that in a new notebook. So that's easy. Load to data frame, that's fairly easy. But if you want to create a new SQL script and say select top 100 rows, but from some Spark location, please notice that you don't even need to add anything extra here. Things just work, okay? And you can see the files which are inside of the Spark world, not the SQL world. So these are completely different things. This is the SQL Server world. This is the Spark world. And they mix together in Synapse Analytics in a completely crazy way. And this is very practical. Okay, so you can create as much tables as you want, mix between Spark and SQL, data from one, data from the other, data from any kind of third-party location, and then you can run them inside of SQL scripts, or you can run them inside of notebooks using any kind of language inside of those notebooks, even .NET if you want to, and they will just run. So this is quite amazing that they will just run. Anyway, so just let me show you some of the data, like right-click preview. So for CSV files, you can still click preview. You can also do right-click, and I'm going to do right-click for this one, and then new SQL script for bulk loads, and I can just say bulk load from that file all the way up to, and by the way, I need to change some things. This is semicolon, infer column name, so you need to know what the column names are, and then you can just say continue. A few more configurations I could do, of course, but let's just say continue, and then let's say create a new table, so new live table. Okay, so I've just created a new live table from a CSV file. This can be column store index or just a heap table, either one is okay, and then I can just say automatically, and this will just create the thing, or create a SQL script where you can see the results in a SQL script, which is, if not exists, create that table with those fields and then copy into those fields the results of that table. So I'm going to run the whole thing, and hopefully this will create the table itself. And if it all goes well, give me a second while this is running, you can just go here. This is for the dedicated one, by the way. So 1 second, let me just find this one. Okay, and this is for the dedicated one, so I need to refresh on this one. And you should have two tables here, so new live table, and then let's say select from this table, and then you should have the results, of course. By the way, the other one is the same. I created this one just a few minutes before we started. So you have the results here, so you can run this from here or from anywhere in your applications that's inside of that. So all of this mixing together is great. And if you want to get stuff that we saw before from the other one, so let me just do one more crazy demo. From here, new SQL scripts, select top 100 rows, so that's fine. Let me just say, I can just copy this. In theory, this should also work here, but using the serverless one. So if I can go here and say new query, as long as this is the serverless one, if I run this, in theory, this should also work. Yep. So you can see I'm in Management Studio, getting content, using SQL, getting content from a Spark engine. So this is quite amazing. Now, anyway, all of this you can do, and then you can create, of course, any kind of notebooks. You can run machine learning inside of that. By the way, there is some extra things that you can do here for machine learning as well. Sorry, wrong one. For this one, you can do machine learning from here. This will grow bigger in the next few months because this was not here maybe 1 month ago, something like that. And then you can just say enrich with existing model, and then you can just say text analytics, anomaly detection, something like that. And then from here you can just say continue and get some stuff to process this. Or you can just you have some file, you can just do machine learning with the new model, and then you can define what model is going to be, target column, whatever result you want to get. I'm not sure what. By the way, this is not a table for machine learning. It's just a Parquet file that I came up with. So please don't worry too much about the contents. But then you can run this inside of a specific Spark pool, and then you can just do all of the configuration that's necessary. And then, oh, by the way, Azure Machine Learning Workspace, you will need to add something like this, and then you can just say continue and run this using automated ML, similar to the one we saw before. So you have the advantage of getting things from different data sources altogether, and it is very practical. And then, of course, you have the development here, the development area where you have all of the scripts. And remember, you can add as much more as you want, data flows, and Power BI, etc. You can add them all from here, and from here inside of the pipelines. So here you have the pipelines. Inside of the pipelines, you can even schedule tasks that run once a week or something like that, or once a day, that get all of the information coming in from multiple places, and things just run. So should be okay for you to try. Okay, so this is Synapse Analytics. Let's go back for a bit And let's go back for a bit again for here. And once we talk about all of the machine learning, all that's left is for us to talk about cognitive services and how you run them. So yesterday I had an hour to show you all of the cognitive services available. It wasn't exactly enough time for me to demo how to use the cognitive services, but today this is a good time, and in the next 10-20 minutes, hopefully something like that, we will be able to demo some cognitive services and then show how to execute them. So anyway, let me just go. Oh, sorry, not this one. Oh, my fault. So first of all, it was here actually. So first of all, how do the cognitive services work? And yesterday I've shown the slides to explain this. So first of all, you have your source of information. Let's say this is an image or some text that you need to process. You send this over to a server that you can control, or something that's a web service, something like that, something you can control. And from here you ask some stuff, you authenticate yourself in whatever way you want based on your application. And from here you move on and send the requests to cognitive services in Azure. And this can be face recognition, custom vision, whatever you want, right? And then from here, the Azure itself will do the processing. And from here, the information is going to be returned. Typically, it's a JSON file. It's going to be returned to your server, and your server will define the kind of way it wants to present the information. So yesterday we saw a lot of face recognition where we defined rectangles around the face. This will be something that this part here will take the JSON file, process the JSON file, and from the numbers from the JSON file would generate those squares or actually rectangles. And from here, of course, you process the information there and then send it over to whatever human interface you have. This can be a car, like the example from yesterday, any kind of IoT device, cell phone, robot, whatever you want. Okay, so this is fairly simple. Wait a minute, this is too much. Okay, this is fairly simple. So let's have a look at how to do this. And to do this, I'll actually start with a new window. I think it's easier. And from here, you go to azure.com. So I'll show you one example of images. And by the way, all of the examples that I've shown yesterday are very similar. So you go to products here, AI, machine learning, cognitive services. I've shown you a lot of different examples for image cognitive services, speech to text, text to speech, text analytics, etc. So I've shown you a lot of them. The processing way to do them, so the SDK is available. The REST APIs are all very similar. So as long as you know one, you should know all of the other ones. So I'll give you an example for one, and you should be able to see all of the other ones in a very easy way. So for here, let's go and try the vision, and then you have face. Okay, so face, we saw yesterday that face was very easy to use. You can detect landmarks in faces. So let's go to browse and let's try to find some actual faces. Almost close, not this one necessarily, but this is close. And then you have, let me just move this over here. Doesn't really matter. Cognitive. Okay, so you have quite a lot of images here. I was actually in the wrong place because I was loading from the other one. So from here, let's say we take I don't know, an image of fake Borat. Fake Borat is okay. No, actually, this is the true Borat. The other one's the fake one. This one is the true one. So you get this detection model, but let's try the detection model number one, which has more things. Okay, and this one has, of course, a lot of information about gender, male, age, etc. We saw all of this yesterday. Emotion, so mostly happiness, but some contempt. Borat is a very controversial character that the actor plays, so it's supposed to be like that, so it is okay. And there's a lot more information about the face geometry and things like that. In this case, there's only one person. If there was more than one person, you would be able to see here that you would have more than one face ID. In this case, you only have one, but you can have more. So let's say with this one, you have at least 3 people. This one has more. Also 3 actually. So here you have some face ID, face ID, face ID. This is the first one, but then somewhere down here you should have another face ID here. Wait a minute, another face ID here, and then somewhere down here, you should have another Face ID. So at least three. One of these is not happy, so neutral, happy, happy. Okay, so the one happiness is 0, neutral is this one. So the last one, which is actually the one in the bottom, is the kid. Okay, so we know this, it's the kid, but if you went up and trying to find the age, it would probably tell you that as well. What? Too much. So smile, gender male, age 1. Yeah, that's pretty much okay. Remember what I said yesterday? The age can be different. Up to 5 years old, it's very difficult to predict. Okay, so don't assume correctness up to 5 years old. Okay, or over 60, 65 years old. Don't expect that much correctness in terms of age. Okay, because this is very difficult to train. It's very difficult to get just training of babies, for instance. It's very difficult. Anyway, once this is done, we need to understand how to run this. And to run this, you can just go down here somewhere, and they keep changing the location, but you have, first of all, of course, you create the free accounts, or have an account already. You go to the Azure portal and play around with it. I'll actually leave this running for a bit. Sign in. Yeah, this is okay. This is a new window. You didn't sign in. And then you can go to the tutorials. So this is the one that I want. So let's go to the tutorials. Actually, wait a minute. Let me do it like this so that I can go back on this one. Okay, so let's go to the tutorials. And now you have client library or REST API. So let's try the REST API first. This is very simple. And remember that this is connectivity using REST API. So I'm actually doing this in a raw way at this moment. I have an image. I need to process that image into bits and bytes, and then send those bits and bytes into a REST API that's going to be sent to the web service. Okay, and then I get a result back, which is JSON, either the results or a fail. And this is going to be the same as machine learning. Okay, so prerequisites: Azure subscription. You need to create a face resource, so I'm going to do that now. So you go here to plus, you create a new face. Okay, face here. Okay, and 1 second, you say create. And then from here, all you have to do is to say pricing tier, free standard. So just use the free one. All of the rest is very typical to the rest of the thing. So I'm not gonna explain this in detail because this is exactly the same as the ones we saw before. Important one here is the pricing tier. Okay, and you need to confirm whatever. So legal stuff. Once you create this, you have here, and I already have one here somewhere. I have here a face object for cognitive services. So you need to create for different cognitive services. You need to create different objects. Content moderation has one. Bots, of course, are a different one. Text analytics. The one that just says cognitive services in general are for everything that doesn't have a specific one. Translator has one, etc. So all of these are, in many cases, different. But let's have a look at face. And here we have. Okay, so here we have some metrics about usage, etc. This is all Azure. So we have here quick starts. Okay, so this is nice. This is an important part. So quick start, they explain how to do it. You have a C# quick start. This one that we're going to see is actually going to be REST API, but then I'll show you the C# quick start as well. And then you have something which is the API console. And this is important because I will try to use this. I'm not going to use the code here. I'm not going to run Visual Studio here, although this would be very easy to just load. But I want to run this manually using the Face API here. So yesterday I did this here for text analytics. Today I'm going to run this for Face API. So let's start with the quick start. So quick start, first of all, you get the pre-requirements, which is all of the objects that you need to create. Of course, you need to have the image files, JPEG, PNG, etc. And then you need to detect faces in an image. You can do it like this with curl if you want to. So this is a way to do this with curl. And then you have to add the subscription key. And then you need, too much. Let me just say copy. Wait a minute. It's probably easy to do it like this. Let me just say copy. Then notepads. Probably easy to do it like this so that I can see things. Okay, so here you have to add your subscription key here. You have to add your endpoint here, and this information is here in the face object here. And then all of the rest is to specify what kind of values you want. Return face ID true or false, landmarks is equal to false. You have to look at the documentation to see all of the parameters which are available. But basically, in the end, you run a content type something, 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 and then you ask to execute. And this is somewhere in Wikipedia, so this is easy. Okay, you can try this for yourself if you want to, but you need this one and you need this one. And to get that, you need to go here, keys and endpoints, and from here you have your keys. So let me just copy to the clipboard. I will need to use this. And then the endpoint is going to be the facebigbrother.cognitiveservicesazure.com. This is a personalized one, so I will need to use this one as well. And let me just put this here. So let me just, well, wait a minute, I did copy, didn't I? Copied, okay. And let me just paste this here. Oh, for some reason it's not pasting. That's strange. Okay, that's a bug for some reason. It doesn't want to paste. That's very strange. Why doesn't it allow me to paste things? That one. This one works. Okay, no worries. So I will use this one. Okay, don't worry about the actual keys. This one is also important. Some cases, so I will use this one here, and then so you can use this as I usually have a notebook on the side, but let's use this one here. Okay, so anyway, you have the keys now. So with the quick start, you can replace all of these values and then just run, and then you get some results which are similar to the ones you see online. And then you can process the results in more detail. I'm not going to go into a lot of this here. Alternatively, you can run this in C#, Python, Go as well. Other cognitive services, they all have the C#. And remember that C# is exactly the same as Visual Basic, except for the semicolons, of course. And with the Python, many of them also have Python. Some of them have Go, some of them have JavaScript or Node.js. Some of them have Java, so you can try some of these. But let's look at the C# one, which should be easy. So first of all, you have create a new C# application. I usually start by creating a console application, but you can create any type. Doesn't really matter. You can use the Visual Studio IDE, or you can use codes if you want to. Okay, but the IDE, let's keep the IDE as well. But this is easy enough. And then from here, you just import all of these things. By the way, it's just copy-paste. You import all of these things as copy-paste. You can change whatever you want, but basically it's a copy-paste business. The only thing you need to change is subscription keys. Well, this is the one. Endpoint, this is the one. That's done. So you solve the problem immediately, okay? And then from here, all of this, you get all of the information here. So for the ones that are on top, this recognition model number 3 is the current one. You can get recognition model number 2, which is older. Some of them are better for some things than for others. You need to look in the documentation to understand the differences. But for instance, for text, the current version of texts, version 3, text analytics, does not allow for multiple languages, is still in processing. So you use version 2, which works really well. For images, you also have similar logic to this one, so you need to decide which one you want, and things should just work. If in doubt, you use the most recent one. That's always the logic. So you have some information about how to do some things, so some objects and codes, and then you can just create a new face client, and you get the credentials, etc. So that's easy. And then you have the image base URL. So this is going to be image / and then the name of the image.jpg or something like that. And then you might have one or more images, and then recognition model number 3, etc. And then you can just run the thing. So you have a few images, and then you add to that directory, you complement to that directory, and then you just call for each image, you call on the await client.face, okay? And this is just all you need to do. So you need to run this, but then you need to specify face attribute blur, gender, makeup. So you need to include all of this, okay? These are the ones you want or not want. So you include the ones you want and exclude the ones you don't want, okay? So this is very easy. And then you get the results. So X detected faces dot count detected from this, etc., etc. So from here you just need to process the information coming out, and this is not JSON because this was already processed, and this is a class that already has all of the values. So detected faces has a dot count, and then you can go and detect each individual face. For each face in faces, in detected faces, you can go and face dot rectangular, etc., etc. So you can go to each face and get the emotions, etc., and then just display all of the results for all of the values that we saw before. So this is very easy. Remember, you can do this for faces, but you can also do this for any type of other cognitive services like custom vision, for computer vision, for forms recognizer, anything you want. The logic is always like this, and you have two things which are different. You have the REST API, so you can call directly with any programming language as long as you can do an HTTPS requests, and you can also, by the way, HTTP is also possible, but be careful. And you can also run using the SDK, like you see here, that creates some classes of objects, some classes that actually allow you to get the information out much more quickly. So if you have a programming language that has the SDK, use that one. If you don't, use REST API. So simple enough. And then you can also use the other one, which is to detect faces with detect faces for comparison, find matches, etc. So all of the detail will be for next and the next and the next cognitive service. You have, this is for all of the face documentation, some tutorials as well using the client SDK for C#. So this is not that much different than this one, to be honest. Okay, so they do have some examples with Scott Hanselman here and a few other people that usually have some videos here. This is very typical, and they explain how to do this. But you can run this for face. You can run this for any of the other cognitive services that are available. Anyway, I still want to try this with the face API directly, and in this case, you want to detect faces. You can also do other things like group faces by similarity. You can identify a person. You can verify a person. These are actually very similar, but then this one that says find similar is a different one. So this is just detecting from A and B, which if they are similar or not. You have quite a lot of this different ones here, but for now I will keep it simple. So let's say face API. So let's say West Europe. This is where I have all of my things, and then I actually have bits of code that I will try. I'm not sure if this was going to work, but we will risk it. So return face ID true, return face landmarks true. So I'm going to go and say I want everything. Return face attributes true. So I want everything. Recognition model, I'm not going to touch this. So let's say assume 3. Recognition model false. I could say true, but that's okay. Detection model 0, 2. And time to live, etc. Face ID time to live. So it's 1 day by default. Now I need this one. So this one is from here. Seconds. Where's this? So okay, so I need to get this one, put this here. So this is the easy part. So hopefully I have example.com. So this is going to fail, by the way. This is going to fail, bad response, and return face landmarks is not supposed. Okay, detection 2 is not supported. So let's say, okay. This is the different bug. Now, before I do this, let me just change the image because I know that image, it might actually exist. I'm not sure. It might actually exist. But let's change the image to one that I know actually exists. So let's say send. Still bad requests. Yeah, return face attributes. Yeah. I always get this. Yeah, I always forget about this. Yeah, no worries. Let's see if this one works now. And then reply, still wrong. Face attributes. But it's... Oh, yeah, okay. Wait a minute. I have to leave it blank. It's different. Okay. So 200 is good, okay? And you get the response coming in, and in this case I have face ID, face rectangle, etc. If I were to add a different recognition model, so instead of 3, let's say 2, where is this? 2. I might actually be able to do some true one here and some true one here. I never memorize these things, but it's very easy to try. And there is documentation about it. Oh, sorry, it's detection 2. Yeah, my fault. You want to get detection 1. Yeah. Remember, this is the same as what you saw here. So you had, where's this? Where's this? Okay. Oh, some bug. Detection 1, detection 2. Detection 2 is actually much simpler. So that was my bug apparently. Okay. So let's see if this works. Still wrong. Are supported by detection 1. Okay. So we need to try different combinations before this works, but that's okay. Okay, this one works. Now I have more information. So face rectangle, face landmarks, etc. So I have more information, and there is more, but I don't memorize these things. I would have to look in the documentation. Have no idea what the exact names are, but it's just a matter of adding those parameters and say I want more of this, I want more of that, etc. And they will just be added to the lists and make it as simple as possible. Remember, you have multiple detection models, multiple recognition models as well. And this is just for face, for computer vision, for other services as well, text analytics, etc. They also have different ones. And remember, you have here your API sandbox here. So you can always go from here and say quick start, go to your API console here and play around with this. You can actually play around with much more than this. Okay, so let me see if I can. Sure, if I can find it like this. It's one of these addresses. I'm not sure which one. So you have all of the possible ones. So from anomaly detection, auto suggest API. This is part of Bing now, but computer vision API. So quite a few. API 2.0. 2.1, etc. So please be careful with some of these versions. Some of these support some things, they do not support others. And the list is actually quite big. So if you go all the way up to the end, you can see that if you say all, this is going to be a huge list of things that are available, plus all of the locations where they are available. So you can try all of these here and use this as a sandbox to try your own. But remember, you always need to create the objects first. Okay, so check the documentation. As I mentioned, you have the face objects. You can also have the sorry. Okay, you also have the translator objects. You also have things like text analytics, but then you also have the generic cognitive services. Okay, and things. Oh, sorry. Cognitive services, and then you have things like computer vision, immersive reader, even cognitive search, sentiment analysis, etc. So you have quite a lot of different objects that you need to use for each of those, but each of them will have its own address and its own key so that you can use it and call it from your applications. So as you can see, this is very simple. Of course, this I would be repeating everything I said yesterday if I was going to show you all of the cognitive services all over again. These are very simple to do, so just have a look at the session from yesterday if you haven't done so already. This is quite fun, and of course we will try to see all of these results as best as possible from the documentation. So here you have documentation for face, but you can also go all the way up to cognitive services here and have documentation for all of the others, and you can do this as best as possible for all of these different services here. Anyway, for today, I think this is pretty much everything that I wanted to cover. Okay, I'm not sure if anyone has any questions before we go, but I am available for any kind of questions here. Remember that after this session, so this is of course live, but after this session, this video will be on YouTube. So if you want to reach out to me, if you are viewing this video later on, feel free to contact me using social networks. Just go to andy.pt, and from there you should be able to be redirected to LinkedIn, to Facebook, Twitter, etc., so that you can see or contact me at any time. So, not sure we have any questions at this moment. I don't think we do. Okay. So that's all right. So in any case, I want to thank you for being here. Or if you are seeing this in the future on YouTube, thank you for watching. Thank you for being here. Hopefully next time I will be able to go there to Singapore, but in person, because of course if you do this remotely, you get no food whatsoever, and in person at least you get some food out of the deal. But I want to thank everyone for being here and for watching this. Please give me some feedback if you'd like later on through social media. But anyway, try this out. Have fun with the cognitive services. Have fun with IoT. Also, have a look at some of the other sessions, especially the workshop for yesterday with Azure IoT Edge, where you can use some of these services at the Edge itself, and have fun with Azure generically. So, thank you all for being here and for watching the session. And also, thank you very much. For having me here. So especially to Priyanka and to Setu for having me here. And see you next time. Okay. Thank you very much.